let's see. I think this, oh yeah, I got to make this one smaller too then. Hold on. This one's got to be shrunk a little bit. Shared screen. Okay. This should resize. Oh, that's a little difficult for me because it's resize these tabs. All right, that's something I was going to show you guys another time with FIU. Darn it. It's yeah, it's, darn it. I got to open this tab back up so it will give me more tabs. See, I need that stuff to the far left. This guy's 1, 2, 3. Boy. So I'm going to do it too. Well, I see your comments to the right. Let's start off with, I think it's the articles over here. One tab over. And so what does it have in common? This this Florida crack bridge, this Pensacola Bridge. Well, FDOT is holding back. To be sure, while FDOT officials assess that they are scrutinizing the cracks and to look out for more. So we're back to the word cracks again, not single cracks. They've also played down the risk of such flaws. Well, we already know they've done that with Florida International Bridge. Characterizing them as not uncommon. Okay, so not uncommon. Interesting. That's a hell of a word. They're not sharing photographs. But Matt Morgan, an Orlando attorney who represents some of the FIU bridge collapse victims, disagreed. Based on research that his legal team is doing, quote, in my opinion, cracking in an older in-service bridge is common and to be expected. Structural cracking in a bridge that is still under construction is not yet in service is not common and can be indicative of potential dangerous problems. It is not common for an engineer to design a structure, concrete structures. Let me get you this structure with some images here. And we'll get to this. We'll get to these guys, is what I found on this. So it is not common, and this is, it's the playbook, if you will, of this bridge, literally this bridge. And I'll share the links, and we'll talk about, this is literally part of what they should be doing. Now I'm looking for gamma. Let me find gamma. Let me find the gamma testing that's required on these cracks. So this is the bridge. This is literally an image of the Bay Bridge. I'm sharing this from North, whatever this is, that link there, or that thing, guy right there. It's literally the bridge. This is the bridge in service now. This is the bridge next to it. They call these sections here trophies. And I'll show you why, it kind of looks like a trophy when you're done. But the cracking is going on the beam system. And these are the beam systems, the girder, beam. They've already installing the deck, and all the piers appear to be in place. Let me bounce over one. Delaware Humane Society. That's where I found the cat at one of my properties there. So I got to take him there. I'm going to take him there and get him neutered tomorrow. Pensacola Bridge replacement. Okay, let's go to here. And what do we have here? I don't want to jump past it. Nope, I can come back to that. This is literally, let me scroll up, 95 pages of, let's see what the title is. Great. Florida Department of Transportation, all design build firms, financial item. This is that bridge, addendum number 1. This will be that bridge, specific to that bridge. There's Skanska. They're the contractors in play now. So here's some data. And what I can do is I can do command find. So we can do command find cracks. All right. So nothing. And then we can look up, what is it? Repair. On repair, we have 27. Ultimately, their contract for this thing, the repairs are mostly for the existing structure to work on that. But we're going to run across gamma testing for this prayer. So I do gamma. And I come up with 2. So why is gamma testing so important? This is addressing the cracks, and this is the whole thing that they already have a playbook for this bridge. It should simply be gamma tested. Gamma is, for you guys, let's see if it's here on the tab over. Well, that's not a tab. Let's go here. Let's go back to the Bay Bridge. So if you haven't been to Pensacola Beach, blah blah blah, there's the bridge structure. This is where they're doing the This is the fit out section for doing the prefab on ground, exposed, not in a controlled environment. So the only controlled part is here is the ground. That's it. There are no other controlled environments. This isn't being done in a giant shed they built and controlled environment at all. This is exposed to all the elements. So now you're going to get the sun drying it out. You're going to get the earth. I'm sure that they might, I'm sure, I won't say that. They should have some type of surface at the bottom of this that doesn't allow the absorption of the water from while they're casting it to go downwards. These have already been cast, obviously, and they're in a drying area. And the forms are stripped. That's important because forms, the life of the forms, here's what one of them looks like as it's getting ready to be done. Now, you'd like to see this stay in forms a lot longer. These are what they call part of their, I just said it, part of their trophy design is what they're calling trophy. And the low bang points are here, here, and here in the cantilevers. And I'll show you other images and talk to you about it. But right now we have, this is the cage, if you will, the wiring reinforcement. So a casting yard on Bayou Chico, whatever. This is where picture left, and I guess it's not picture left. I guess it's picture above. So this is just showing it, and I'll get you specs. But they're talking about the length of it. The length of it's 150-foot beams right here, 72 inches high. So it's pretty cool. You know, they're 6 foot high, 150-foot beams. The rendering, when I looked at the rendering of it, it was odd and shows this per their drawing. Per their videos. Let me see how many people are floating with me right now. You guys are, let me see if I'm missing something here. Okay, hello 9 people. John, yes. So let me do this and hopefully the chat will move over. Yeah, it did. All right, so we're taking on data and then we'll wrap it and then you'll see what you do from here. So this appears to be some type of weird temporary support. Interesting enough. But back to here, and this seems like this is a casting to protect the casting from the elements. Interesting enough, again, perhaps this is where they, as I'll show you in the video, where they have to fill these holes they created. This is sitting on piers, 4 piers, 1, 2, 3, 4. And I'll talk to you about how terrible that design is in a moment. But you can see after they have the structure, the beams up, they put down a structural floor system. It appears to be steel. And then they pump concrete in. Skanska's the builder, well-known builder. This I also think is a nightmare waiting to happen. This appears to be all concrete also. We're back to this concrete. Guys, I love concrete. I just think that this is just ridiculous to do this concrete, you know, to do arches in concrete. Really, we got cracking. They cannot even predict and stop the fucking cracking on a concrete I-beam they make. So then they make a major span out of what appears to be concrete. I just don't get, Florida won't get away from this shit. And this building in his comments, you can see here back to February 18. I read some of them. Won't distract you on that. This is where the beams are going. 1, 2, 3, 4. I don't know if there's just 4 alone. Give me a minute to scroll over. So this is, I'll share this link. And as we see, 1, 2, 3, 4, 5. So you got 2 here, 1 here, and 1 here. And again, 1, 2, 3, 4, and it seems like a 5th one on the outside. And let's go back to this image. God, I can't pick it off. 1, 2, 3, 4. 1, 2, 3. Total of 8. So 3 in the inner, 4 on the outer to the bridge, the existing bridge. And we come back up here, and remember we're talking about cracks. And we're going to assume that all of these are 100% the same. You know, you got to do, I don't know, they do 1,000 of these, I think it was. It's somewhere in here. They had to do 210 spans. Let's see. In total, the bridge design calls for 210 spans. 210 of these spans. This is a span from here to here. 210 times 8. So it's 105 each for the east-west-bound bridge. So you can do the math. If this is 8, 1, 2, 3, 4, I'm sorry, did 8, didn't I? 5. Really confused here. 3. Maybe there's nothing there. Maybe there's nothing there yet. But let's move on. It's very hard to find any images or data on this. FDOT scrubbed their I couldn't find it. They scrubbed off the design, the actual designs. They're no longer existing. So, but what they didn't scrub is the contract. And so we come here to FDOTs, and this is off of FDOTs. Gamma. So if cracks are so important, repairing all the detected defects and conducting post-repair integrity testing using 3D topographical imaging and gamma testing logging. Okay, so gamma is beautiful. Let's see, is it over here then? And here's your gamma. So here's your gamma. What you got here, buddy? Can you hear me? Somebody's messing with me over here? Nope. Let me see if I can. Thanks. Audio and video fine. Thank you, Doss. So gamma testing. So we're talking about these FDOT cracks, and they won't share. Simply, they should say, "Hey, look, we got some cracks. For being honesty, they didn't create the cracks, but it's fucking crazy that they're protecting the interests of the contractor, the engineer, everybody, but the public. Clearly, if I have no sweat in the game, I can clearly say, yes, these are plans we approved. The engineer promised us, the engineer of record promised us that this system would work. We agreed to that he 100% stood by it, and that's it. And with that said, public, do a video, public announcement. And with that said, we're going to make them do the same thing we require of in the contract for the existing structure as cracks appear, that they must do gamma testing. With that said, it's going to determine exactly what's going on with the cracks. But I'm going to show you where FDOT says, oh, we're going to rely on the engineer of record to make the evaluation, and we're going to participate. They're taking this back seat. It's like, fuck, it's like somebody's paying off people here, that they're not standing strong and proud. Now, this link is literally came from their further links. So we can't really guess with this cracking. This is not the same as the Florida International Bridge, because they have everything. Maybe those are crowns. This is an exaggerated crown, if you will. But those spans, perhaps they're crowns. So we can't really tell. We don't have the ability to guess as easy where these cracks could be. But there appears to be multiple cracks. But under the contract, under 450-199 to be specific, pre-stressed I-beams built up and deflected data. That, if you follow this 450-199, you wind up here at 450-I99, right up here at my mouse. And this is what appears to be a crown, if you will. I'm going to simply say crown for you guys. It says vertical and horizontal curve spans. So they're, what they're calling that. And I should just call it what they call it. Let's see. They call it a camber and build up. So we're going to call it beam camber. So they're calling it beam camber here, and then here they call it vertical curve. All right. So you're not wrong no matter how you describe it, as long as you get to the same target. So then we have U-beams. These are unrelated to that. But I thought in the rendering it was more like a T-beam, but it appears that they've gone to I-beams. So again, so now we have a contract that they signed 2011, 2016, that they would, for existing structure, see Pensacola Bay Bridge replacement. This is not dealing with, because we got to put it in context. That's number 13 as I scroll up. The design build firm shall be responsible for the following: evaluating geotechnical conditions, determine the threat. Let's go up a little further than that. Yeah, I'm pretty tired, so perhaps I just misspoke. I did read this earlier. I felt like this was with the existing structure. Drill shaft foundation for bridges and miscellaneous structures. The design build shall determine whether the resistance factors used for the drilling shaft will be based on static. Okay. All right. So that's them determining that. I don't want to get all excited and say that that's for this new structure yet. Huh. Okay. Performing cross-hole sonic logging. Oh no, this is definitely, this spread footage is not allowed. This is definitely for that existing structure if they have repairs, if they want gamma testing. So we get to update my comment. This also dealt with existing structure. So 5095, page 50 of 95. And there's two of these. Okay. And that's where I'm getting confused, because when I Google repair here, when I try to find repairs, it dealt with maintenance of existing bridge structure. So I'm crossing over my brain. Sorry about that, guys. The damage recovery cost of design build, the items listed above. Malfunctions malfunctions and are not repaired during the time described. Costs will be assessed beginning at the appropriate time. And let me confirm something here. Caused by design, build firm. This is the electronic system, so that's going to be under that repair. So each repair is 27 of them are specific for. And again, don't think this is for that new bridge. It's also allowing for the damaged old bridge. So this could be easily read into that and not the other one. But the plan will outline right. And again, this is the electron. So if I go back to gamma again, and this is what I look for. I look for gamma on this one because ultimately this is one of the best things. So apparently, unless I'm drunk now, mind drunk, that apparently they're required to do gamma testing. And I'll share this link with you. Oh, wait a minute. I can chat too. So I copy that. I move this over here. Yeah, let's see if it allows me to load it. It did. So page 50 for gamma testing. I'm gonna say please Google gamma testing, and you guys will understand the significance of how awesome gamma testing can be. So there's it did work, didn't it? This link work? Can one of you guys click this link over here and tell me if it's a solid? Right click your mouse and say open a new tab, if you will. But tell me if that got you to where I just did, because I'm going to delete that so I can work my way out of this. And I'll wait for you on it. Actually, I copied it, so I'll delete it, and I'll look for your comment just now. Great. And cookies. And back to that. What the hell? What's this, a magnet sticking to my ass? And the Bay Bridge. We'll get to that one. Don't want to jump on that yet. Let's put that down there. A little bit more out of the way. Yeah, in fact, I guess I won't be getting to that. All right, where you guys go? Where'd you go? Right here. Anybody test it? Clicking that link, please. Turns out I can test it myself. And page 55. Yep, that works for me. So I'll bail on that one. That link works. Now we'll come over here, and you guys you can scroll down to find from that page. You can scroll down to find it, and I'll get rid of this one to find that one. There's your density log testing, and it will tell you your voids. It's gonna spot your voids. It's going to do that, and now it appears that that's a requirement. Nothing there for you guys. And one more over. Okay, and I'll share this link with you right now. And this link, hey Blind, what's up? So I'm jumping on this. So this link is for a source of images and other data as of this date. So that's the one right there. This northern here. So this should link you if you click on it. Right, open here. It should link you to this, which is going to show you the setup and the distance spans reported. And 150 feet, it seems to be solid. I saw it somewhere else too. And the 6-foot height on the girder system. The design is so difficult to find. So these guys are below grade. Take note of that. And this is a real image. So let's jump over to, I think I have it ready to load a video. That's a rendering. This is FDOT talking about it, but we'll get to that. Should have a rendering ready. Nope. More data. And FIU. All right, I'll just go grab this one for you guys and share it with you. So this one has Skanska as the builder. I have the engineer for you guys to share for it. We have here, work on the bridge was halted twice, April 5th, and this is very interesting. April 5th and the 16th of this year, and again on June 26th and June 27th. Gamma testing, you're not going to do that, this result in one day. So if there were cracks, you know, this I find amazing that they were able to resolve within, 24 hours following discovery of cracks during the routine inspection last March. A routine inspection, FDOT said. So, and right here, this I could see taking the timeline to do that. Now they need to take one of those girders, those 150-foot girders, put it on ground and break it. They need to cause it to fail. They need to load test that thing and see what's going on to see why these cracks are happening. It's nothing. That's a very cheap cost. It's nothing at all to trash one of those girders, especially if you tell them the clock stops while you're testing or something like that, because they're worried about getting money. There's a bonus involved, 15 million or some crap. I'm going to give you this link on this one, and this is some good stuff. This one comes from this press right here. They're the ones that originally were on top of it, I think. Since cracks imports the Pensacola Bridge, right? A Florida Department of Transportation spokesman. This is a different spokesman. They have another one that dealt with this. Responded to the follow-up questions about the cracks. She said the agency and its contractor, Skanska USA, are currently evaluating various remedial options. Therefore, no repair methods have been initiated this time. So the bridge is going full ahead. No repair has been determined. They haven't determined what the total cause is. They're not disclosing it yet. Further, despite urging from some area local officials, FDOT has declined to seek evaluation of the cracking from independent contractors. Amazing. So FDOT, even though they won't sub it out. Other than those already part of the state team, and we already know that they couldn't predict these cracks again. Let me tell you, cracks are 100% predictable in concrete. Under tension, it sucks. And this thing can really, it's fragile while they're moving it and it's not under post tension. It's really fragile stuff. All right. Grover Robinson of whatever, county commissioner, who is running for mayor, he also said, told a reporter that he wants an inspection by someone who wasn't already on FDOT's payroll at the time the cracks developed. That doesn't make sense. That doesn't make sense at all. That doesn't get you anybody. So, so in other words, they still will be working for FDOT. So of course they have an interest for working for FDOT. But Robinson said that he and commissioners in both, Rosa County are powerless to order an outside investigation. From what I understand, this is Florida Department's money. This is not federal funded money. So therefore, literally, NTSB would have nothing to do with this in theory because it's not federal funds. I want to make it clear this is not a county bridge. Robinson said, okay, we're still waiting on the complaining in an email to FDOT officials. Right. It is unacceptable not to tell local jurisdictions when there's a problem like this, which I agree. Extent of the flaw is uncertain. Meanwhile, Skanska has declined to answer news media questions about the cracks, referring reporters to FDOT. So we went full circle. FDOT's doing the hound protecting. Same thing they're doing with this fucking FIU bridge collapse, that they're running interference. Now we don't have NTSB stopping them. FDOT uses NTSB to stop, their excuse. Oh, we can't give it to you because NTSB says no. Well, now there is no NTSB, and they're still saying no to sharing images. FDOT is the common denominator of not allowing the people to attack the whole thing, to bring it to a halt, to scream and holler, which is still withholding some basic information. The key question is how many cracks are there? Well, that's really what they're all about, right? And they retie into the victims of the fatal pedestrian bridge collapse at Florida National University last March. It's tied back in. But as last Friday, FDOT hadn't specified the number of cracks, so FDOT's holding back. And the new Pensacola Bay Bridge, nor released photos of them, if they have any. FDOT said agency officials are considering a request from this newspaper for media access to the bridge work site. So once again, FDOT is running interference. Once again, FDOT is, you can't tell me FDOT's a real fucking highway department now. They're clearly political and must be paid the fuck off. What are you going to do, sue me, FDOT? Well, you should be releasing this shit. But Matt Morgan, an Orlando attorney who represents the Florida victims, disagree based on the research that legal team is doing. In my opinion, cracking in older, right, we talked about that. So I'm going to give you this link real quick, and then I'm going to close out this tab, and we're going to get to that rendering. So where are you hiding? Over here, and I'll see your comments now. So this will be link to, I think this is the original finder of the bridge issues. that they somehow, I- I'm thinking somebody leaked it to them because obviously, they don't know what they're looking for. They're not engineers or anything when they go, if they did go out there. So somebody must have leaked to them, we got problems here from somewhere, everywhere from FDOT to the contract, one of the contractors maybe knowing that something's wrong. So you can bet this, because they're not saying how they got this data, right? So obviously this is leaked. And there we go. And that does work, I hope. Testing. And will it load? This is okay. There's your article. And I think that's your original article. So let's bounce out of that one. And so I'm going to give you this link now. This is, let's see, 24 pages. It's dead. It's got dead links in it. FDOT. It's from FDOT. They scrub the links. You hit the links, you're going nowhere, baby. So I'm trying to find out, who might have had it. This is a rendering. You see the different design. That this is solid. The rendering initially had solid. Now they change it to this weird ass new design that I'll explain to you. I think is shit. This is on the compression. The new design's got compression, tension. It's got a lot of drama going on. This one has pretty much what appears to be one span allowing it to go through. This one appears not to have, well, let me scroll down. Come on. This actually is this is a live link, so it's actually slow for me to move the page. I'm trying to move the page. Huh. With that said, download, right? I should be downloading this because you know how FDOT scrub shit. So, download. What the frick? Right in the way. Shit. No, I didn't. I see it now. Okay. Sorry, I thought I'd stopped the live feed, guys. I thought because you saw what happened. It just, something moved away, and I was like, what the hell? All right, so look, this is the original. Remember, we got the original designs, and this is an I-beam construction, and we have 1, 2, 3, 4, 5, 6, 7, 8. They're spare in English. They appear to be 12 foot apart at one point, and they change to tens. And this is a walking recreational size at tens, shared use path they call it. Interior, we got the tens, and then they got 12s. All this matters because these guys will have more loads on them. So this is 10 foot apart. So this one and this one and this one and this one, these interior ones would have more loads on them if we're looking to look for cracks, and these all being the same size. This would have the least amount of load. It doesn't have. So let me help you out. This beam here, split the difference between here and here, and it gets that load. This one split the difference between here and here, and this one gets that load. Split the distance between here to here, this one gets the load. And we can see that this is least amount of load. So if cracking is happening under load, say they got the decking on and you have cracking, then now that means they didn't design these, obviously correctly. And if this one is not cracking, say all of these interior ones are cracking, then you could say, oh, okay, so this would have been enough. And we can calculate or guesstimate that it's that little bit of extra load of the concrete that's causing this extra cracking. So ideally, you should not see cracking in this one and this one. If they do disclose these images online and we see cracking in the outer ones, you guys can extrapolate that these should also have cracking or should be damn near close to cracking. Any one of these having cracking, pretty much since they're all duplicates, should all have cracking except for if it's load-based. That is, the cracks appeared after they put the concrete on. And also this appears to be it is a concrete member, but it's so close to this one, these loads are going to transfer back down to this guy. So if this is installed also, this is another one that's taking more load than the rest. Aha. And we have this cantilever with this concrete. This has to be calculated there also, but I don't think it equals the same. But nevertheless, there we have it. And this would be a two-way slab-ish, I'm saying out here, because it has a cantilever, an overhang, and there's not a supported overhang. It doesn't have cantilevers, brackets, if you will. Now, I want to get back to your comments and look over there. This was the original design. As you can see, the view. This is the new bridge and existing bridge. It's much higher. And let me, come on, scroll, baby. It's really stuck. I had it even when I wasn't going live. It was doing this. I just want to show you that I don't see that it was a suspension bridge in the original design. So once again, like the Florida National Bridge, they originally had a rendering that was different, and then they switched over to some other bullshit. The final contract is something else. They had it, the rendering shows no look. If this is the rendering, it shows no suspension bridge. No. All right, let me scroll on. All right, that's it. Let me just give you guys a link because that shit's taking too long. Original rendering from FDOT, and I'm gonna say scrubbed links. Scrubbed. Oops, I had it right the first round. Scrubbed links. So you'll find some links in there. They've been scrubbed. They've been 86. Now, talking about something here needs to trigger me again. Original rendering from FDOT. Scrub links. Too many characters. 6 characters too many. Character. There you go. You guys just gotta break that apart. And we'll click on it, see if it works. And right now it's working. So if you guys sharing with other people, give them this, let them troll it and see what they come up with. This is the original Pensacola Bay Bridge from them. Remember, this is sort of the same thing we got problems with that we had initially with the first bridge, is that we found these things like this and we went with it, and it turned out that they had an updated plan. So this time we know how FDOT plays us. We now, we're going to have to be ready to be flexible to move on. Okay, so this has got good data in it, or some data. This is from the Pensacola News Journal. I got to keep this tab open because they want me to pay for it if I close down this link again. So I've got to keep it large, if you will. It's sort of a trick my server does to keep them from reloading. Okay, right. So this whole people, they basically cited the first people I told you, and they added these senators' comments. So Senator Braxton said Thursday that he was not previously made aware of the cracks, but said cracking in concrete is not unusual in a large-scale construction project. Useless fucking data. He said he had learned that he has learned that in this case the cracks were caused by the concrete curing incorrectly. Now it's perfect data. So initially the senator is bullshit, nothing useless, but he's a senator. They responded to him, and this is now a fact we have. So now we got a fact. He said that he learned that in this case, the cracks were caused by the concrete curing incorrectly. Aha. This puts us over here to that where they're doing, going this direction, where they're doing here. So this is where the concrete curing incorrectly problem is happening. So in the staging area where they're doing this is where they're not monitoring it, which I find amazing because you have to monitor everything. Again, we're back to where they're not using sensors in the concrete. So once again, we got a $300 and $400 million fucking project, and they're not putting simple sensors in the concrete to see the drying times inside of it. I mean, there are people who are building buildings that are so worried about their pads and the life cycle of their pads that they're requiring and accepting the extra cost of putting sensors inside the concrete while it's being installed, so it can be monitored and to get their pads perfectly load, to be able to take the loads that they're putting on them, these industrial loads. Now, this is the life-threatening loads, and they're not using sensors in it to say that, hey, that one's drying too quickly. We obviously need to stop this pour today, and the sun is killing us because we're out in the elements now. You got sun, you got wind, you got humidity. Humidity can work in your favor. You got the wind and the sun here that will not work in your favor. Overcast days work in your favor, but you can create an overcast day by putting this damn thing under a giant tent. But $400 million doesn't get you a fucking tent. You know how this is just ridiculous. This is just triggering me. All right. So I heard you say shit. Sorry. The outside would have would have curb and railings though. It's to protect the the traffic from bouncing you. Now per what they said, it's going to be a concrete thing. I want to put my advertising here. I keep seeing this advertising. All right, a casting yard on this is where the casting yard is. So going back to this one, I keep this one open, and I think I gave you guys this link. I'll give you that in a moment. So back to where'd you go? Nope, I'll give you that. Back to this. So we got a senator giving us a known fact now. Unless I don't think he's lying. So we got the drying staging area. So now we know where the crack's originating from. So we're talking Skanska building, quality control, cheap fucking bastards, FDOT not monitoring themselves, not being there, saying, because you can use a chart, and you simply use a chart and you can literally see the wind. You can literally put an air meter over it. You can literally do this math. You can literally have a tool that the sensors that are inside the concrete that you take readings from. And for a bridge, you think they would do it? No, it's too many of them. It's they got to do 1,000 castings. We wouldn't want to have quality like that. We'll just roll a fucking dice. That's all. There's no question about it. It always concerns people. I'm confident the state. Look, now he's confident with the state. I'm confident the state, if they had to, will bring in additional engineers. Oh, that means that's back to meaning nothing. Okay, concerns over transparency. So now we're back to the Gulf Breeze mayor. Talks about his vision. So he's got issue about it. Still others are concerned about FDOT's lack of transparency, particularly in light of the March 15 collapse. Okay, so remember, this is a different article. This article, it tracks me back to the original article. Gulf Breeze mayor, blah, 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 said he does not want to rush to judgment. He's a politician, right? So the news about the cracking in concrete for the new Pensacola Bridge is concerning, although I'm not surprised that the contractor did not make public information about the possible defects. Yes, I'm not surprised at that either. It's not in his contract to let the public know he's making cracks in his work. So, Skanska is very huge, guys. They're international. I certainly would have hoped that FDOT would have made the community aware of the issues he said in the email. Now, interesting. I don't think FDOT should have to make it aware either, public aware, unless you guys have a policy change in Florida that says, look, cracking appears, you have to make it aware, put a public post out there, period. We don't want to hear why. We don't want to, there's no way around it. If cracking appears, must be disclosed, period. Even if it's a current day, just have to disclose. If it's going to be, if it's installed in the structure, has to be disclosed. If the cracks happen on the ground, document it. And yes, still disclose it, because it makes the contractor accountable, and you can see what he's doing days before, days after. You can document, and other engineers can learn from it. Raise the question of rushing the project for incentives. Right. It's a $15 million bonus, guys. If you don't know it, that's why you see the highway guys working late night with lights on and everything else. They're racing for the bonus. And if you guys don't know it, when you see another vehicle go by with these sensors on it, they're testing the highway for levelness, and it has to be level, or they don't even get their bonus for that. Sometimes they have that as part of their contract. Hopefully this highway will have the same levelness requirement. The news are possible, and then you see the grinders out there middle of the night with dust blowing in the air, because then they're grinding it to that level. The news of possible construction defects with the bridge leads me to think that an independent inspection team should be brought in by FDOT to evaluate the defects and recognition of the tragic consequences of the bridge of FIU. Okay, so now let's look at the structure. Here are this is the whole thing being done at one time. This is on a, wait a minute. Am I seeing this right? Right. This can't be right. I was going to say this is on a barge, all connected. I'm thinking of the rendering, and I'll show you the rendering thing in a sec. Buy photo. Yeah, I like it. So when they're putting this into place, they strap it at the top here. They lift it up. So this puts this under tension, this connection. And I know that per their drawings that they do this in 3. This is a lift. This middle section is a lift, concrete pour. And this bottom is a concrete pour, making connections with reinforcement from here and here. So you can imagine you can create a break in there, a strain inside there. And we'll jump on. I don't think there was anything in here besides, oh, this guy. He's representing FDOT. This person, rather. I don't know if guy or girl. You can't say genders anymore. This person, Seifert or whatever, said in the email that once the cracking was identified in the Pensacola Bay Bridge, this is a representative of FDOT, the concrete placement operation was evaluated to determine the cause of the cracking. He wrote the contractor modified. This is what I find very interesting. He wrote the contractor modified the materials and placement methods, but did not offer details about who completed the evaluation of what revised materials and methods was used. So Skanska, appears unilaterally, figured out that the cracking was a result of materials and placement methods. So what the hell did they do to change everything, and why? That's the whole thing. If they can tell you why, and then what about the existing ones? So why aren't they also having all the issues? And they're existing. I'm sorry, they were existing when these cracks showed up. So what about the other ones? Is it now predictable that cracks should also be popping up? Other crack. Okay, so we ignore that. And I'm going to give you this link now because the rest of you guys can read and link you up to this one. And we have, if you ask me if they should be measuring the cracks in the ground, and once they are set, yeah. So the cracks appeared after they were installed. This is what they're alluding to. After they were installed, and I'm guessing it's before concrete was installed. And I'd like to say it was my theory, and I'm extrapolating, is that once the concrete decking was installed, the load was applied, and then we get cracking. But then the Skanska is saying it's because it's not because of wrong engineering, which would mean the size of the joists are wrong, the beams are wrong, that it is those magical many, and I don't know how many, beams, girders, are exhibiting cracks. And that's because when we were casting them, we being Skanska, that we had a material problem and installation problem. So material and installation problem. And also disclosed, and capital letters, disclosed. What did they disclose? The senator found out they disclosed, they disclosed, because we can use the senator's words on that, as you know, he got the data when they spoke to him. What did he disclose? All right. It was caused by, he said that the cracks were caused by the concrete curing incorrectly. So again, that puts it back on embankment. So everything I was saying, it ties together. So it disclosed fabrication. Now, I'm trying to say it's in the prefab, disclosed prefab materials. And installation. So abbreviate now, huh? Oh, I can get away with it. Here we go. I'll do that and make you look at it that way. So there we go. So this appears to be, let's let the link load. This runs you to where, let's just verifying. Yep. This puts you in that article there and done. And that's that Senator one. Moving over. So now we have another Florida release showing just was January 12, 2018. Interesting enough, this is the engineer. This is Brett. This is the engineer record. So we're back to that engineer record stuff, right? So here's our engineer record. And wouldn't you fucking believe it? He's a teacher of engineering, had a university. So now we're back to this boot too big to fail. We can't shoot down the university professor. He works for a state university and all. So it just goes round and round with Florida. As someone said, they're just fucking a trash can of corruption. So here is Pensacola 3 Mile Bridge presentation. So he was going to do it. He did or was going to do it. I couldn't find a presentation. You can't find it. I was going to purchase it even because that would have got me the inside link to the damn video from the engineer talking. But that's also now not available. And if somebody could find it, guys, I'll pay for it. I'll pay for it. $50. I'm good to go. I'll pay for his presentation about this bridge because you can't beat better than the engineer of record talking about a structure like this. It really is worth it. I get to write that up for continuing education, in fact. Even if it's bad, it's still good, solid information. So January 12th, 2018, it was 12 to 1. It was a 1-hour presentation. And it was collated to Pensacola, Florida. It was 28 registrants. If I could find them and right click, open link. So as I do this, we find it. Oh, wow, it's gone. Brilliant. Okay, so much for that. That's, huh. Okay, moving on. So look, I'll pay for that if you guys can find this guy's presentation of this bridge, because he actually sees a senior vice president and principal with whatever incorporated. So just like Denny Pate, he's a principal, he's a vice president. So now we're back to the guy having sweat in the game. He's not just signing off; he's a senior vice. It's like so many friggin' parodies here. It's just crazy. He is serving as a construction engineer and inspection CEI program director for the Pensacola Bay Bridge construction project. Correction, I guess I got that wrong. He's the CEI. Sorry, guys. But he was talking about this. You'll see. Brett earned a Bachelor's of Science degree in civil engineering from Brigham Young University in Utah and has more than 31 years experience in heavy construction. Okay. This experience includes construction of segmental bridge. This is not a segmental bridge. As well as conventional and long span bridges, long span bridge, and interstate highway improvements. For the past 5 years, Brett has taught graduate level highway and bridge design. He's a bridge design. He's taught it as an adjunct professor at the University of Florida in Gainesville. So now we have this guy who's going to be who's the inspector, the university thing, the CEI. CEI is the same one that we had for that bridge that wouldn't document properly. So now we can't find the CEI programming for this. This guy presenting this. All right. He was born in Pensacola, another Floridian, right? So it's just too many connections there. But I would have learned all this good stuff and it would have been great. I'm going to give you guys the link. And I have to give a little correction to that. It appears that he's only the CEI. And that's my back down. There's his name. And here's the link to so CEI, remember they're the inspection engineer. We would love to find that data on it. His name is, let me get, yeah, great. Wait a minute. Right, so you guys can look up, he's a principal, if this is his connection. So he also has sweat in the game. Remember, if, he can't say he missed it, etc., that he evaluated the structure, because they do all that stuff. And he dropped the ball too. He didn't see this cracking coming. And especially he'd be there when they were doing just like the CEI was there while they were doing it in the staging area. But once again, and he would also require the gamma testing. Learn how the 3-mile bridge is, here you go. See how to learn how the 3-mile bridge design encourages pedestrian access. Learn how the sustainable marine, how to learn that, how the marine construction recycling program, environmental impacts. Well, anyway, I'd still buy it to see what's going on. Anyway, you got the links. Delete. And, that was a test. So, all right, the registrants. And delete. FDOT's release of this project. Photos, map, meetings. Now, FDOT's $400 million right there, right? All right. It's supposed to... Level of service criteria in this design year for 2040. Traffic and projections indicate that the 3 lanes of traffic in each direction will be required to meet the minimum level of service criteria. To 2040. It's 4.16 miles long. Estimated completion 2020. And I'm trying to find all types of back ways to find it. So if you guys want to find this, you try to find this all the connections from the township to the bridge. They just really have blocked so much stuff that you can't find it now. They're a little smarter now. Look at this rendering now. Is on this page, we have this concrete, nasty ass structure. And those links, they do have weird ass links. So here's a map. Your connection is not private. Come on. See, it's just Google. Well, I'm talking to you guys. They changed my settings. So what do? Not secure here. Great. Well, there we go. I won't be getting into that. I'm going to give you those guys a link too. Did I just lose it? I should have backtracked it. Brilliant. Let me see if that link is good. Let me give you that link real quick. And is that the same as that one? It is. Looks like I got the right link. And this will be, I don't remember what the damn link was. Oh yeah. FDOT, one of their disclosures. And let's click it. And there it is. Now, am I still in here? Yeah. Back to safety. Let's load it then. And it looks like that's not happening. And one more time. Block, cookies valid, site settings. I'm going to bail on that, even though it's from them. I'm going to trust that Google doesn't like it. I don't like it for now. And going back to, I'm going to give you this. So you guys can get some stuff off of Facebook. This link here is, let me click it and I'll give you the link. I don't have Facebook. So, oh shit, it loaded. Believe me, they bounced me. I'm going to give you the link. Facebook gave me a teaser. Link to images and data. Please share with me what you can find. What you can find. I do not have Facebook. And I will not have Facebook. There you go. So that's that. Let's see, do it again. I can only stop them loading. If it can stop loading, come on, let me see it. Hold on, let me see it. Don't go anywhere. Don't go anywhere. Did that work for me? Did I get it away with it again? I confuse Facebook sometimes by enlarging the screen. Don't ask me how that shit works, but I figured it out some time ago. All right. You saw I just couldn't get it a second ago. Many here's in the background, me not being able to get it, have to sign in. Many have asked what will, and that's what I told you about. If you enlarge the page, I play with internet stuff. What can I say? I don't know. So if you guys can remember that trick, you might work for you too. Many have asked what will be done with the concrete debris from the demolition. That's the recycling thing. I know about that. Shit. Looking for cracks. So they're using the rendering also. They put vehicles on it. It says on the construction. That's going to be the probably a safety lane for running vehicles. This photograph, I can get you guys this video from the FDOT site. This is just FDOT site stuff. I'll give you a link. This is not an FDOT site. On the Pensacola side, the bridge construction continues. No, I think this is one of the images. Date on that is what? July 20. Here's a look at the steamships, July 19th. Okay, that was nice. I can't go look at this anything else. I don't want to leave out of this because part of it is leaving the mouse in here somehow locks it in too. Sometimes it won't come back. But we got it concrete. Okay, July 17th. Now we know this is where the problems happen right here. Here. Yeah. So those are the Wow, that's interesting. That's the bottom of this trophy. The trophy's multiple sections. This is one section. See how it stops shy right here? And then there's another add-on. Um, well, it's casting differently. I stand corrected. So I'll show you in the FDOT's version of it. This was going to be 3 stages. This appears to be 1. This is now 2. And the bottom is now 3. Joined together and then taken out on a barge and lowered down. This is good data here. This is where they're running into the problems. Is that a casting member? One of the 150-foot long spans? I don't know. This I find intriguing. The amount of, it's like reinforcement, I believe, is what you're looking at, sticking up. Very, very interesting. So the one crane will, this is cast there on top of some dead men. This is kind of cocky any old way it is. So they're just laying it down. So this would count as disorganized yard, overlapping. This is organized, but then you've got this product over here, this one here, this one here. Why one in the staging area here? And let's look at their staging area. So components. Here's another one over here. There's another one here. So this stuff takes a while to set up, to cure properly. There appears to be some more here, here, and here. Perhaps more here and here stacked on top of each other. This is a U shape. Oh, it's upside down. Is that part of their casting? Yeah, she's kind of wrinkled. Perhaps this, I spoke too soon. This appears to be a tent, a casting tent. So you can eat my words on that one. This would, if that's a track or not, would retract and pull back in while you're casting out of the sunlight. Very interesting. Maybe it's added now, and maybe not. Maybe it's not a tent, but it looks like one to me. Let's read their crap. Here's an aerial view of the concrete casting yard on whatever. Concrete components such as piles, trophy piers, pieces, and beams are fabricated at the casting yard and sent by barge to the, shut up, cat. More than 200 workers are employed at the casting yard, along with an additional 250 approximately at the bridge construction site. Yeah, whatever. And I must zoom that in. Hopefully I don't lose it by zooming in a little bit. Nope. Ooh. Almost press like. Zoom in. Okay, why would this person like it? Oh, view comments. I can't do that. I don't want to do that. Drivers will encounter nighttime July 6th for what? Alternate lane closures. Oh, I'm going to try to zoom out just a little bit more. Hopefully it won't default and kick me out. All right. Let's see what else we got from them. The Blue Angels flight demonstration. Nothing, any data there? Nope. This page is dedicated to this bridge. July 12th. Okay, back to the Blue Angels. Bay Bridge. A row of trophy pieces are in place for construction of the new Pensacola Bay Bridge. The trophy pieces are connected horizontally with the concrete beams. The bridge deck is then constructed on top of the beams, which I spoke to you guys about. The trophy pieces are massive, about 250 pounds. They're lifted into place using barge-mounted construction cranes. Okay, so here are trophy pieces. They're dual 1-2-1-2 sistered systems. Interesting, they got a connecting piece here to keep this stable, obviously. No trophy pieces installed at this point. So they are fabricating on, not, as I said earlier, that they're picking them all up and dropping them down as one. That is the base. So that base, I said those base, they're here. And so this does follow, this is very weird. That does follow what they're saying, and that's rebar reinforcement. And I will show you, if you can keep that in your mind, what it looks like. And there's your cantilevers. As you can see, these loads, these are the reinforcements, are down the center of these trophy pieces, and also in the cantilever, the weakest points you can put them. As far as compression is always the best point. This standing straight up, awesome. This is where they're doing, I guess at this point, we're probably well, oddly, because how can that be next to it? No, this is formwork. This is formwork we're looking at. And so here's a finished cast piece. This is formwork of these two together. This holds this in place while concrete is poured between this section right here and the base. Weird. And the base. Remember why I'm saying weird. See this section right here and the base? Okay, we'll come back to that image. Why I'm saying weird is going back to the yard. Going back to the yard, this is a base. These just need to be connected. How much distance? It's going elevating also. So this allows for, okay, brilliant. This allows, so all the tops will look like this. If you can imagine, this bridge has an elevated platform. At one point before they transfer to a different design, I think near the top of the platform, that super high crown of the bridge, if you will. Since you're going up, you could cast different section heights just by having a flexible engineering, if you will. Now it's idiot proof. The base, these bottom of the capital, the bottom of the trophy will be will always marry the same. But the height can change by changing the interior piece here. And that's why I said brilliant. That's actually brilliant. I like that. So going to this, right. So as you get taller, you then get to use a taller piece. As the bridge works its way down, you use shorter shuttering, formwork. So that's pretty damn cool. Let me see if I don't lose you, if I can see your comments. Oh, where you at, Matt? You're over here. You're actually over here. Let me see if you got any comments for me. All right, let me see comments. Linda Fig could be brought in console. Oh, William, that's an awesome comment. Those dimensions are for lane widths, not girder spacing. I'm not sure, Dale, what's the dimension? Yeah, yes, exactly. Yeah, wait a minute. No, I'm not taking no back, Dale. Dale might be correct. We're going to revisit that, Dale. We'll revisit that. Thanks, Dale, for checking on that. So here's a look at the work underway at the Pensacola Bay Bridge. And I love how Dale jumped in. Please, guys, you see me playing this as I'm playing it. So if you see something like, I think I was out showing one of the bridges, another thing live, and I kept wanting, I knew it was 15%, but I kept coming back to 100 on my degrees instead of 90. And I kept calling it 24, 25%. And I forget who it was, kept saying, no, it's 15. You're going to 100. Basically, I said, yeah, you're right. I should be going to 90. Sometimes, you try doing these videos and doing it live. Your brain gets all twisted. It can get twisted sometimes. Well, this can cause casting problems, this right here alone. And I'll explain that to you. Remember, I'm also a contractor. So they're driving into pylons, which will be cut to height. And so this vehicle, this says a few things, this image. And you guys, here's the truck. So this means this is pumping at this point. These trucks don't come out and just say hi in an empty truck. This is now there. The riggers are out too. The outriggers are out. So the concrete's got to pump. It's got to pump, go around this turn. Oh, another turn. Got to pump, creating more force. Got to create another more force. This creates a lot of force. That ultimately, when it gets to here, it's now freed of all that force from here, and this turn comes down charging out of there. Can actually hurt your workers. This truck should have been placed further out. This whole boom should have been extended. So this is telling me that they've got some logistics problems here. Interesting, they are protecting the workers with a barricade, or protecting this part with a barricade. But this is a logistics problem. You'd have did better using a damn a smaller pump truck that just had pipes and a single hose. This causes segregation also in concrete. When the forces blow through, they can it's just nasty. That is, I see as unprofessional. Skanska gets the failure on this. As they're driving the pylons down, you can see this one then gets a lot of deterioration. We'll get to this on the cutting of the pylons in the water. In fact, I should give you a teaser on that now, because this is an awesome image. Hey, I'm glad I got to this link. Here's your pylon driving machine. That's the concrete. Yes, it can be driven. I think they use a 20,000-pound driver on this. So it can drive into the, shut up, cat. Anyway, so I'm gonna leave that open because that might be helping me. That cat's horny, man. That cat, I'm getting him taken care of tomorrow. Poor thing. Um, okay, where are you? I want to show you, and well, I'll give you that. I'll just probably load the links up on this stuff. I want to show you. Come on, where's my live video for that? Oh, there's another FDOT related link, and I'll give you that. It's nothing in there really. Okay, here are those videos, and I'll give you the link for that. They're on their page that they're sharing. And with that said, this I'm going to click on and show you some errors, if you will. But this is a rendering. Are those real cars, or because they got perfect separation? I mean, they do friggin' such great CGI, man. You can't even tell anymore. You know, it looks real though. Okay. Oh, here's the CGI. Right. My brain's frozen. So you can see them lifting up this big section here. There's them all in one section though. And that's that. Remember we saw the shuttering. I called it the formwork. And here's your base, and here's that design. As you can see, this will be a short section. And maybe they can fabricate the short sections down here like this. But take note of how these are out of the water. Very important to take note of that, because I'm going to show you that when they drove these, they had to cut a lot of these under the water to make this whole system work. So it wasn't that flexible. It was really firm, and they had to go in the water, which I'll explain some other crap about that. But as you can see, this is moving around. And I'm going to show you where this is also a structural thing that that alerts me to something structural. Remember, I'm a structural guy. You're right about, well, one more time. Right about, and there. So you can't put any reinforcement to tie in from here into here. This is setting on top of these to the right. So let's call this a shelf. So this sits down on this shelf. Now this would be grouted. Let's give it a little props. And you see the next image. Grouted. Screw me. And one more time, got me. All right. So this will be grouted as you saw. So what is the grout? Well, the gravity of the bridge, so it grouts it, it makes it one. So this and these piers move as one laterally. Of course, you don't need uplift because the weight of the bridge is going to handle the uplift of the hurricanes, et cetera, like that. So that's not really an issue there. What's the issue though? All these loads, visualize the loads here, right? So all the loads ultimately come down to these two. And some of you guys love punching shear. So let's talk about that. This could create a punching shear pushing through the center, because as you can see, it is not aligned over top of any compressive moment. It has to share its compressive forces out to these piers. And these are also piers. The whole system's a pier. This will be a pier cap for these. This is a pier cap for this. Altogether, they're calling it a trophy. All right. And so these are your piers also that hold the pier cap. And these pier caps, and this is a rendering, are of an arch design, a partial arch design. And this, if you look at it, it's a cantilever. So the loads, and I'll show you the reinforcement, which is amazing. It's not really spectacular at all. There appears to be no post-tensioning in it either, or pre-tensioning either inside this system. So it's all calculated on the dead loads to be resisted by tensile strengths of steel, the reinforcement cage. Just so you guys think of that. So now the loads come down here. It's a cantilever, so it has to transfer its load down here. Coming down here, then from there it's got to make its way out to all four of these piers, sharing all of them out. And I'll show you the steel cage of that to give you an idea. And this is what that formwork would look like. This is sort of their rendering of it. And this is that tie-in that I didn't see before, tying those two in, that platform. And interesting enough, because now it's no longer that. Now it's this one. This is the taller section, if you will. So now this is the adjustable one. So the tops appear still to be same. Then here we go forward, and there's the concrete. And that's just for rendering of it. And let's bounce out of that, and I'll see your comments in a second. And how do I bounce out? And go here, 39 seconds. I guess I won't see your comments in a second. So then there's them there guys driving the 140 foot long, a 30-inch square test pile. Whoa, okay, remember this is test piles. I'm going to talk to you about that. Yeah. Test piles weigh approximately 126,000 pounds. They're test piles. Look where they test them. Think the test piles are done here. not out in the bay. They're done in a protective cove. They're not the same soils. All right, period. Once they determined where the loads, the friction can take it, they then did their extrapolating and they came up with the height of all the piles they should make based on the water depth and making this work. With that said, they came up short, I think, many times because I don't think their intent was to have these, the base underwater. And I'll show you what I mean by that when we get to it. And the governor thing is just a waste. And come on, cat. Okay, awesome. I didn't look at all the videos. So there's the casting members. Appears to be the formwork, but there's no tent there. There's no tent there. It's 150 feet long. You got me. That one too. They're I-beams construction, although the rendering looked more like a T, but in real life, they came out to be I-beam. Thanks for this drone video. And there's the formwork. I would guess for that. And here we go. And there's I-beam there. And there's the casting. Oh, they doubled the video down. And they shortened it. In that case, did they elongate it? And no. And one more thing for you guys. There's the 318 video. Nope, nope, nope. 221. Back to this concrete design arched suspension bridge. Concrete. This is just friggin' ridiculous to me. Interesting, the connection here. I saw it. It appears to be on steel, but I don't know. So this is back to the same thing with FIU. If you just think of this as no longer having concrete around these things, you're looking at the cable, trying to anchor in concrete, pulling down on concrete, putting in a compression, and also some tension. And there's this decorative, they have to get this archy stuff again, right? We're back to that. There's the overhang, the archy overhang. And there's the underside of the structure, as you can see. And you can see they get the different sizes. As I was explaining, that thing is awesome, pretty good engineering as far as making it flexible. And let's get out of that. There's existing, and there's the other structure. We'll fast forward this one. All right, it's before and after. I saw this one, and nothing to see there. Okay, so I'm going to give you this link to this one because this is FDOT. This is not Facebook. I'm going to give you that link, and then we'll see your comments. Where'd you go? Up here. Those dimensions are all right. Thanks. We'll get to that. So here's the link to I don't have to say the link. Renderings and video design, video CGI. You guys got that. Bouncing over to, so you saw that one, and I said I would talk about this in a second. And also my man's spans. We got to get to that. Pensacola Bridge. Right, the test. Yeah, so now I think I just give you this one. I got to test that link again. Yeah, it's highlighted. So I gave you this link, so I'll close that one out. Bouncing over. This is what I'm going to resume the video now. Hopefully it'll jump back in. Good. So this is a live video. Oh, it's that 3-minute video. But something in here, though. Something inside this one. Bear with me. No sound needed because I think it's just music. Or maybe I found this video and then I found the other one linking it together. I don't know if I can scrub in this video. Yeah, I sure can. It sure is. It's the same one. So off it goes. That's a waste. Oh, it had data behind it. This is me working on Skanska. Their funding, their lobbying. I do that, go that far too. And also the guy that working on it too, that senator that spoke up about it. I want to see if he had some sweat in the game. I couldn't find him having sweat in the game at all. So the Senator Doug Broxton. So I couldn't find him having any connection there at this time. Remember, they update this crap. that's what I wanted to share with you. Lobbying. I'm going to jump into lobbying real quick over here, and it's going to help you with the FIU since I did say FIU and all. So lobbyists just don't tell a senator what we want you to do. Lobbyists do this. And so this is literally a lobby ticket, if you will. I'm calling it a ticket. And this shows them what they're going to do. This is for their money. And this is for the Uganda. Uganda was going to monitor this. This is what the lobbyist proposes. I found the document under the DocuCloud, whatever. And this is what they propose to help out the Uganda country. And listen to it. Shall include the following: manage media relations and monitoring all media globally with an emphasis on the USA. This includes print, digital for coverage on the president and the Republic of Uganda. So lobbyists do this stuff for you. So remember, they hired lobbyists under Florida International University, guys, and we can't find out what they're doing. Well, they're also doing this. They're looking out for their clients. So they monitor it, and they find videos like mine, and they say, is it a problem? They watch the count. Are people bitching and screaming, saying, we need our senator to do anything? They look for the noise. If there's no noise, they can report back to the client, yeah, there's plenty of videos, but the noise isn't going anywhere. No senators are coming back to me saying, I want my dibs. I want my money. No senators are coming to them. But let's go on for this. And for ease of reference, the consulate with category, look, for each story, capital, this is what they're going to do. For each story, caption and record the title, media source, radio, TV, internet, etc. Okay, on and on. Lobbying services. For the duration of the contract, the consulate, the consultant will undertake to carry out media monitoring, reports to the president of the government. So again, I'm going to give you guys a link for this one so you can understand what lobbying does. You can read it as much longer. So I'm going to give you this, and I'm going to say and I'm capitalizing this, what yes, do, and how it relates to FIU bridge collapse. And so they do this, and also their structure if there's one. So that one I just linked you. Let me confirm the link because it was hard to find it, and I want this to stay for you guys. So I click it. Yeah, I mean it's 12 pages, so now you guys can work your way down and see what it's about. That's a 2015 lobbying ticket, if you will. Let me delete that one. Let me bounce over here. Let me delete this page and give you one more lobbying ticket. So this is another lobbying ticket, 1977. Interesting, right? To look at the dollar amount for $4,000, whatever money. So I'm gonna share this with you. This is 7 pages. And you know, print 4-color kit, so it's the same. So I'm showing you what I'm showing you, 1977. As what I'm showing you is that it's the same shit all these years later, 1977. They're still doing the same thing. Monitoring, all the stuff. And you know, look at this, print documents, control radio interviews, check that out. For $105, $1977, right? You know, so don't get that. So I'm gonna give you that too. And 1977 lobbyist version of the same above. I'm gonna give it that. Bounce this to you guys. Check the link, and that's pretty cool. And so you can see that what the Department of Justice, registrant, blah blah blah. And you can see what it's all about. And you scroll down to whatever page that was on. You got to read all. You got to read this crap. It's what consumes my brain, right? And let me delete this. But you can see how the lobbyists work now. They're not just trying to buy off somebody. And over here, I went back to Manila looking to see if they had anything current. You keep coming back because they'll update. I did not find anything current. Deleting. That's FIU. We're going to do this on Saturday if you guys are game. And just for anybody who watched the other video, it awesomely that I took my drone inside that bridge for anybody who watched it and who's watching now. Oh, that shit's spliced up. Remember I said I couldn't find any splicing with the video from live feed? When I sent my drone in there, I found a splice at every one of these locations that had a bolt in it. I'm going to leave that open. I still got to do more research. And FIU bridge collapse. Law firm quietly lobbying Congress for FIU. So I went back over that, see if anything changed. Everything status quo. And that's under that one, lobbying. So we'll go ahead and tie that out. You guys can Google that one. Again, I went back to research O'Neill again to see if there's anything updated. There's no updates. With that said, I'm thinking this lobbyist job is now monitoring what we just saw and saying, hey, if there's no noise, fuck them. Fuck the public. They can go to hell. So this is salmonella outbreak. How'd I get on this one? Oh yeah, Kellogg's cereal. Well, I'm here. I didn't mean to come over here, guys. But Kellogg's, if you're taking Kellogg's, taking a commercial break now, I do not recommend you eat any Kellogg's. In fact, I recommend that you do not eat any Honey Smacks. It has been found to cause no deaths, but found to cause, oh man, I'm messing up my commercial. Salmonella poison. In fact, Kellogg's and the Center for Disease Control recommends you remove all this Honey Smacks from your diet. All right. I got alerts, and this is one of the alerts. I do not eat Honey Smacks. Sorry, guys. Hope you enjoyed that one. I told you that's for that cat. They do the best deal. I can get it done then. I look Pennsylvania, I look Philadelphia. Delaware Humane Society is going to jump right on it. So for like $100, they're going to neuter them. Okay, so here's the yard, the other pictures of the yard. This is from, I gave you this link. Doubling down on the link. This is the yard images. So I'm going to double down on this link for you guys. Yard images of a curing and design issue. So, and we say design issue of concrete because they admit it, Skanska, and I can't remember how to do Skanska. Whatever. Skans admit it to, what did they admit to? Declared, admit the shit. They declared concrete design and installation of same is an issue. Yet installed bad, effective beams anyway. I like the curse and all, but on that one, because that's the way I would do it. But no cursing allowed on that one. Those dimensions are for, yeah, we'll get to that one. So scrolling over, hey, you guys, 15 of you. So here's the yard. Oh, I didn't check the link because I didn't give you the damn link. And there's your link to that yard. All right. So here's the yard shot, and you can read it and go through it. Here's a real existing structure. The real guy's going in. I want to show you the cutting. Lost it. Damn it. Maybe they'll show it here. I want to show you the cutting of the structure. So I went to FDOT, looked up Gamba, I looked up the few things on the structure, trying to track down those plans. Couldn't get them. I'll come back to that. Same thing with this. I went to FDOT, another link they have, another way to try to backdoor it. Zero. Couldn't get the damn plans. I was able to find the schedule for this bridge. I'll give you the 2 pages. Dating back to there, including advertisement. Okay, so, and that means for the bid, the contract, because apparently this is also an advertisement that this is a old brother contract where it didn't go out properly advertised. If people feel like that it wasn't bid properly, the Skanska just took a home run on it, obviously. 2 pages of offering of bridge design and the schedule. And check the link. Link solid, and I'll delete that. So as you can see, I'm running out of tabs, so we're knocking it down. Try this one again, nothing, dead end. All right, District 3, 10-year cost feasibility plan. This has got some good data in it. This is going to drive me crazy, still tracking down. There might be the hidden inside there, inside here somewhere, the some other data. I have it in it to remind myself to look at it somewhere else. Again, that Skanska, couldn't find it. They were under the take that they paid people off. Again, back to O'Neill, couldn't find anything on that. That's for FIU stuff. Couldn't find anything current. MCM again. So I think they're doing monitoring. O'Neill again. Foreign law. This tied me into O'Neill again. Just trying his different names and versions because these guys are so tricky. They put it under names and versions of names. It's amazing. Now where the heck is my, maybe it's here. Maybe I should scroll down more. Gosh, darn it. Give me a home run. Give me a home run. Oh, scroll out, scroll out. Oh, it got me. Let me try it. Ah, oh, I can get it on top of it now. All right, well, I didn't zoom out enough for that one. All right, so can I click on it? Awesome, got it. Awesome. Okay, so we got, oh, there, isn't that something? Story details. They're linking a story back to there. So this is awesome though, because now we got the end girder system. Huh. There's the crane, so they start from the outside and install inwards. There's the fall protection, great fall protection. Don't see it on this side. Decking's up. There's the design, and that's their article. They're linking to an article. Oh no, this is them linking to themselves. So open link in new tab. Interesting. Is it going to run us back to the one we've seen? Yes, it does. Delete. Next image. Good. We saw this one. This data, I want to show you these damn these things here. Elevation, I showed you these guys. This is just the same shot, but they zoom back. No, this guy's taking it from the car. So he did the article, but they didn't allow him access without that way. These are just supports for the guys that work on the structure. It's no data there. Data there. The two cages up there are elevated over the others. Okay. So obviously we're wrapping this up, but they're now at the decking stage. So these are old images, February 17th. They're at the decking stage. They got multiple cranes and everything working at the same time. This is they're trying to get that money. Skanska is a really big company. They don't screw around. This is, I guess, the mid-span where they're going to do the change. No, it can't be the mid-span doing change of elevations. Gosh, you hear the other cat out back? There's the 150 foot guy. Here's your spacer bar, your spreader bar. And say he's used a pipe. The load transfer there, just shear down here. This is awesome. This is simplicity. And they're rocking it, man. Look, they're putting that over there, rolling this thing over and knocking it out. Skanska really does have the capabilities. Now this is elongated. This is the way you're supposed to be rocking it. This is the approach. This is approach work. It's got nothing to do with. Okay, this is obviously a bucket. A bucket, and where are we looking here? This I'm trying. I think is right on the barge. That's the girder. Nope, don't have it in mind. We can't be on the barge. No life jacket. This can't be on the barge. This cannot be on the barge. Like a little mini turnbuckle of a type, but that doesn't really work as too much of a turnbuckle. So this can't be at the barge, but yet this is a spacer. And that see the cross bracing here too? There he is. So this can be in the barge. Here's his line, his safety line maybe, and he's tied into it. And so I would have to think if you were required to wear a life jacket out there too. I guess when he disconnects, he would have to wear a life jacket. Ah, there's your life jacket. He's on the barge. And I called it as I called it. All right. Hard hat, tied in. There's your temporary cross bracing. It's not steel. This is normally steel. So they're just rolling on here. They're just using 2x4s and whatever that is. All right, let me see if you got any comments for me. And I'll get back to evaluating those cool ass images. None. Okay. All right. So back up here, here's our decking. There's your structural decking. Awesome. And the concrete will go across there, across here, be tying into here also. United Rental, 85 feet, so that shows you where they're going, the max. Nope. 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 Here's your extension. Here's your pier. They're over top of a pier now, I would assume. And nope, no friggin' clue what they're doing. Moving on. Barge, ready to rock and roll. So they probably don't see the spaces on this. So these guys get loaded on here. This gets towed out. You get to give it to one crane. Maybe they have multiple cranes. So if there's two of them here, the rest are already rocking. And so these are probably reloading and send them out. I mean, Skanska really is a big company. They bust ass. Here's a gantry crane lifting up these, bring it in place. This guy rotates, drops them in there. And look at that spreader bar. That's a real spreader bar there. And let's roll out. And there's that tent. I wish it was closed so I can prove that theory. And the yard's huge, all of you over there. And no, maybe the spreader bar's up top here because it's a single crane and it's spaced. So there's a spreader bar. This allows for the taking up of this end and lowering down this end first. So when they're installing it, one's high, one's low. So they can lower one end softly. This allows for the guys to walk down here with that. You see the guy with the hook on his belt. He hooks onto this. He can walk down here as needed while they're tying in whatever they're doing structurally. So you'll see this on all the beams. This little long cabling. And it's not installed yet. So the barge just moves out. Then they'll, at the staging area out there on this barge, they'll install that, swing it over in place. Here you see them installing concrete. You'll find this in other locations. What are we looking at here? Pump truck. So the pump truck will be barged out also. The concrete will go out there. You know, if they start from one end of the bridge, they can drive down. But clearly the concrete's on this side. So that's what you like to see. Vibrator, little man. This gets you your levelness. Here's the roller. In fact, the roller one, this is a screed. This guy's kind of awesome. It's a roller screed. Let me see if you guys want to talk about that. A roller screed. So the concrete is just pumped here. It's over pumped. This guy levels it by roller screeding here. This guy roller tamps it, if you will, tamping it down as it just rolls back and forth, working two directions, like a damn typewriter. Back here, it has a pan and a skid, also for the leveling. And I don't see anybody back here. Here's another guy back here. This guy appears to be, I'm trying to see if it's a long ass roller or another form of leveling, but it's going to be fast as hell because it's still rough and it's going to be getting your depth to your tolerances, your level tolerances. Your lighting, and I have no idea what this is. I'd say it's your post-tensioning, tying down the decking to, but I didn't see any of that anywhere else. I wish I had plans. None. This guy's adding an agent, some type of working agent, I don't know which kind, as you go along to help the concrete with the elements, whatever it may be. It could change per the day, the temperatures, etc. And they got a nice mix. One guy's holding it with one hand, leaning over, so it means they're controlling it pretty good. Ooh, top shot of the yard again. Formwork. Come on, cat, give me a break. That's the reinforcement. That's it. Here is, going backwards. Here's the top of, as I see it real fast. Here's where they're going to obviously elongate and do that formwork to tie into the bottom. And there it is again. So you know that at minimum, this is going to be this long, concrete. This is prefab top units. This is this shape. We're looking at top view, but if you can lay them down, you can see it's got an arch in it. That's that way, and there's some more reinforcement. They're trying to make it like a assembly line. This is assembly line. This would be this arch tying in, and it's just, you know, Skanska gets an A for that. Beautiful cat. Beautiful cat. Yeah, I like your noises. There's that cross bracing. Now that will be changed to steel. I don't think there's any way in hell that would stay wood or not be installed. So their assembly line, they're figuring out their system. Usually I see it installed in steel first all the time out. Wood is Skanska's quick way of doing it. And there it is, lowering down. So you got one up, one down. And there are 2 cranes, not 1. So that's that connection we saw, and this is what I saw previously, probably the same photographer, maybe, but and so we saw it was the loop connection here, and I said maybe the spreader bar is up, and you could just look from one end, and it'd give that cocky tilt thing. In this case, nope, 2 cranes. So I take back that statement, and we're at 2. Ooh, come on, I'll take another image. Wow, they got tons of images. This company, right here, they're the ones you get the data from. So they had access, or they got a hell of a lens. Speaking of which, any guys, my photography people in here, I'm getting Canon to send me a, and they'll be here on the 26th, a $15,000 lens and a $7,000 camera. I'll have it for exactly 10 days. I could lie to you and say like I'm a big boss. Oh, look what I got. Nope, it's going to be a loaner. They're going to send it to me to do videos and photograph for my channel. I was supposed to go somewhere, but my girl likes this cat. So now she's talking about not going anywhere. I got to go somewhere with that camera. I was thinking of going to Maine to tick off some shots. So there's this temporary false works, and it will stay in there for days. Hopefully it's staying there for a week or more. I think we just did round around. I think we closed out. Yeah, we closed out these images. So zoom out. I don't know what else. Let me see if I can shut this down. And scrolling up, anything else hidden behind there? Apparently not. As I close that, come back to you guys. Damn, I wanted to show you the cutting tool. I want to show you this cutting tool, so I think I have to go here and steal from my own video. Lobbyist version, images of curing, design. Going with this one. You should see this cabin. It's terrible. He's jumping up and down, up and down. Ah, UMAX is loading. What the hell UMAX is? My FDOT. It's definitely not an FDOT, I don't think, but let's see. I don't think it was an FDOT. I want to find you guys just. Okay, that was roundabout. Shoot. And there's another boy cat out there. There's a girl cat that lives around here. So they're going crazy calling for her. They're going crazy, but she's been neutered, and somehow they still think she's active. She's got no interest anymore. Gosh darn it. I wanted to show you this guy, this damn tool. It was, I can't believe it. I can believe it, but damn it. Great. I want you guys to see this tool so you can see how they're cut. And is this one? Maybe. 33 images. Back up. Maybe this might be the home run. I want to show you this tool and then explain what you're really looking at. An engineering screw up. Because this guy is this good with how that prefab unit stuff goes. So this would be a mistake. This wouldn't fall under the same engineers. 99 cents per month. The 99 cents per month. Okay, let me go still. Image 9. 33 images. Come on. That I think it's a screw up because he's, well, you know, he was good up until the point where they did the testing in the damn bay and the what do I call it, the alcove, the cove. Renderings. Come on. I think it was one with the girl video. Or I showed the girl video and with the commercial. Or started at 15 seconds. Just about. Come on, close out. Come on. Yeah, no customers, I say. This one didn't work. Let me try one more. Not one more. Let me try this one. So we're that far. Scrub links, I said. It's FDOT. No, that's not that one. Come on, baby. Damn it. It's the girl. 1, 2. Somewhere about 3 or 4 links back, I thought. That's a document. That's the Bay Bridge. I'm going to hit it again then. Oh. It might be a commercial here. It might be this one. But I was also thinking I can go back in my video, not now, but give you guys a link to it. Come on, load up, UMax, whatever you are. Maybe you're over here in UMax. No, you're still loading. All right, so back to this. They cut this with a tool. Maybe it's on this track machine here. Nope. So all these guys should have life jackets on. No life jacket, first off. And is this published by them? Yeah. So my Pensacola Bay Bridge by them. So this is a reportable incident right there. There, it looks like somebody's gear there. Looks like no life jacket. Looks like it could be a life jacket. Half-ass on. So I don't think you can put in a life jacket half-ass on. So without going over both shoulders. So I'm going to discount that as a life jacket. But if there's a life jacket there, as you know, I'm an ass because I don't see it. No life jacket. No life jacket. But wait a minute. There's a rule about falling too. You know, so the fall is less than 10 feet. But he's also in water, so life jacket should be on. Now, you guys know, if you know me, I've told you before, I had a friend die. Was working only about, I don't know, 8, 10 feet off the ground. Using this tool I was going to show you in a different configuration, cutting concrete. Slipped, fell off, got right down here. Say this is 6 feet tall. This guy's 5'11". Say he's 6 foot tall, 6'1". Top of his head, 6'1". His mouth is 6 foot, 5'7", right? Falls down, gets stuck in there, starts trying to work his way out, gets even a little more embedded. His head's below the surface. How are you going to get him out? Well, that's what happened to my friend. He died. So they're setting these up to be cut. They're setting them up to be cut with a tool, but they're not cut yet. So these were driven down. This is an interesting thing because it doesn't give you detail about that. Drivers were encountered. Where's the tool? Maybe it'll show it. The piles are approximately 140 foot long and driven to the depths of 80 to 100 feet using 22,000-pound diesel-powered hammer, which I told you guys about. I thought it was 20,000. Design, guesstimated for you guys. Design calls for 2,124 piles. Sorry. So they're calling them piles, so we're going to call them piles. Most 30-inch square, right? But those near their high-rise section are more robust, 36 inches square. Each weighs a neighborhood of 126,000. All right, Kimberly Wayer. Okay, we're moving on. Here's a look for September 2017. The first test piles driven. Test piles. They did run test piles. The whole length, or some many length, sistering here. It's confusing with the data, but now July 5th posted. So they did run it out there. So you can clearly see the heights are way elevated. This is odd because they're way elevated, and yet the pier, the pedestal base or the trophy base are showing even with the water, where it would be cut here when they finally go in. So this is definitely confusing me. I'd love to know all. I'd love to be the CEI to know all that shit to see what's going on. Crews will be working through July 4th. All right, good for you. I'm going to scrub this page down real quick. Okay, so no data. I'm looking at the images they load, and they're back to delays. They got to post delays. A group of local student scientists from Pensacola, Booker T, Washington School are studying the environmental impacts, of this to see what fish are going on. Okay, Pensacola. Okay, they're sharing what's going on because they got to share it to the public, tell them public what's going on as part of the contract. The barges are being pushed out. So obviously these barges are being loaded out, towed out, because they would just be conflicting with each other. So that's what they're looking at there. If you'd like to receive periodic emails from the Pensacola Bay Bridge, go to info@pensacola.com and click join my list. That would be awesome for you guys. Anybody who wants to really follow this that lives in Florida, go to here, info@PensacolaBayBridge.com, and get on their list. You'll be ahead of me on what they're disclosing. Bridge construction reached a milestone last week. The completion of driving all the piles. Now, this I did know about. So all the piles are completed. Here's some caps going in. And that's configuration just gives me the heebie-jeebies. I'm sorry. When I like that, it's like, bothers me. All right. So that's a weird shit, right? It does. Some weird stuff. Not all of them do it that one. That one did. All right. Nothing really here because it's on shore now. So we don't care about the shore work at this point. We don't care about the shore work at this point. Plans are to open the new. Oh, shit! I got excited. I thought they meant plans. All right, here's my man. My man said, who's giving his credit to? Giving his credit to Dale. Dale, let's go back to here. This is what I was looking at, right? 10, 10. He owns that. That's all lane width. Was that 10 here, 12, 12, 12, and 10? So now I'm still looking at it with spans. Spans are, I'm not trying to fight you on this and see how they look equal here. Spans are still unequal on this structure, as you can see. And also, I can show you that on the pier caps, which I was trying to show you with the Dale. I was trying to show with these damn things here. That here's a configuration of 3, and this is have a configuration of 4. And also the cantilevers and the spacing from here to here, where it jumps over from one pier to the next. Moving on. Oh, I should be over here. Great. Over here, scrubbing it. Scrub faster. We're wrapping it up, guys. Crews are working to construct, blah, blah, blah. Oh, let's see what they say there. Construct the new eastbound Pensacola Bay Bridge. Traffic is transit. Test and, yeah, here's a snapshot of progress through the end of the unit. Test and production piles driven 1,337 of 2,100 blankety blank. So I want to see, right click, open a new tab. Hopefully I don't lose this one. Give it to me. Good. Shit. Let's try that again. Not now. They gave it in full page. Crews are working to construct the new eastbound Pensacola Gulf Bridge. Okay, here it is. 1,000 test and production piles. Production piles driven 1,337 of 2,124. So this is more than 1/2 of the entire side of the structure. If they ran them all, the test piles being all in one line, going all on one side. Trophy pieces placed, 105. Well, if trophy pieces are placed 105, we're past the test and production piles. We're past that. They're no longer tests. They're actually installed piles at that point. So this would, if you're saying trophy pieces are placed, this means this has to imply that there are more additional piles installed that already have passed test. Trophy pieces placed, 105 of 415. They're way into it. They're way into it. Florida I-beams set. Yeah, you got 200 of 1,000. You got 25% of the 20% of the damn structure of the beam set. These are beams we're looking at. So these are installed. So this test and production piles driven. This is just confusing data there. Concrete bridge decks span poured 20 of 210 feet. So interesting. 20. Oh, I'm sorry. It spans 20 of 200. So 20 of these guys, these spans from here to here, 20 of them are poured. So it appears they come in this direction, from this side over. Moving on. The project remains on schedule for completion of the first of eventual wastebound. Keep in mind, schedules may vary. And we will delete that. So that was some good data there. That data was shared June 15th. Okay, so June 15th. June 15th is an important date. That's one of the dates that they were shut down. They were shut down through the 27th at that time, I think, something odd like that, on the shutdown date. They got us on this. This is no longer giving us any hookup. That shit's fucking gone. That's gone. That was on the Pensacola, and I didn't record it. So that's gone. But over here, I remember there was some good stuff here. If you let it scroll, you grab one of the links. Right. Okay. So over here then. This is placing the girder. Let me let it scroll somehow. If I don't screw with it, it will give it to me. Wrong direction. I don't remember those chairs. That's okay. There's one. There's a new one. We'll take that. So I said that's a weird configuration, right? So I saw them move their strap, and this one is designed obviously for the concrete to now settle down. So without loading, without going down, this appears to be the base. It's going to sit on top of one of the bottom pedestals. And let's see if I'm right. You can't tell. So I was trying to extrapolate and then prove my extrapolation, right? Didn't work. Failure on that one. So it would sit down on there, then he would just add formwork and close it up. And this would be extendable too, for the greater height. I think it's beautiful myself. I think it's friggin' awesome. Patent that crap. All right, I'm trying to show you the cutting, showing you that, yeah, I may talk so great about them, but then I'll show you that we'll take it back. So here's the, let's see if they're on, that's just a regular vest. Trying to determine if this appears to be like a gantry crane going to grab it and move it around. So that might be on shore still. First trophy pieces is ready. Yeah, at the Bayou Chicago Concrete Casting Yard. Yeah, so it is at the shore still. They loaded new images. This is a new site. I might not be able to catch that one. They might have caught on to that. They might have been smart. The engineer might have went on here and somehow added this shit. Caught on that one image that's going to catch hell on. Let me see, where is it? Or could catch hell. It's right about here, baby. Right about here. Oh, yeah. All right. So let me see if you guys are there. Oh, you guys there? 15 of you are. All right, thank you. Let's get back here and get you this. Okay, this is a cutting machine. This is a pretty damn doll of a machine. Let me zoom in. This is how you cut the piers. These are wheels, right? There's a motor in here that spins the cutting cable. Cable's here. You put the product in here, and if you stood here, and I start this machine, it slides back on this track. As it slides back on this track, and you're standing here, well, kiss your ass goodbye. Same thing with concrete. So don't stand there. It slides back. This can be configured a lot of ways using a lot of different construction. It's a saw. Now, it's stainless steel and everything else, and it's going to cut those pier caps. And as they call them, the massive trophy pieces will sit atop the piles and consist a footer, column, and cap. So they call them footer, column, and cap. It's like me changing the names of this stuff all the time. No big deal. There's the cage. Let's go back to, well, let me jump on something. If you guys remember, we looked at the video and I pounded it saying that it's sitting on top of these guys, and it's sitting on a shelf and it puts the punching shear in. It's got things like that. That's an issue because the span between these two, it has to span it. It literally has to span it to make it to load paths over to these columns. I'm saying columns, right? And you put them in the water and you call them something else. So it's got to transfer to the piles. Now, you saw them above water when you saw them set there. But I'm going to show you in their own friggin' picture they released right here. That machine's buried here. You're looking at the agitation of that machine working at this point. Here's your life vest, your life vest. The machine's underwater and it's kicking that. It's kicking ass. It's cutting. This strap is going to lift up this concrete after it makes the cut. It appears the machine is, see this ball and the connection? It appears the machine's there and they somehow were able to, they made some contraption to make it stay level and they're cutting it. So now, as you guys remember how they were grouting, now they got to make a cofferdam or some crazy shit or some mix, and it can't be inspected now unless you go underwater. You got to dive to inspect these pier caps now because this is cutting below water. Now, with that said, is this a friggin' bay? Could the water lower, you know, on a tide and you get access to it? Maybe, you know, which would be awesome. But right now, this machine's underwater doing it, and so the whole connection is going to be subject to constant water or of water coming on and off, which is an issue altogether. Because if you can keep a column directly underwater, air's not getting to it. Not the same; it's different air underwater, but it lasts longer as it exposes air and non-air, air and non-air. You know, the water doing that is now an issue. Just like this would be an air appear would be an issue, but that's an issue. I just want to share with that. And it says trim the concrete piles driven on the west side. I'll give you this damn link. This one, bouncing link for you guys. So here is a link. Of course, a link. Cutting pure caps. Pile caps. Underwater. And I might give it a W2F. I will not. So that is kind of cool, right? And messed up again. So that is kind of cool, right? The tool that's used for that, it's strapped. Here's when they were pounding in. You see the break on that one. You saw the other one was worse. Now, I'm saying the engineer is badass, right? Well, why don't they wait for low tide if you're going to cut this? The engineer is badass if there is a tide that's going to go out. I think the tide might be out. If that's a water line, then the tide might be out already, and this is what they've miscalculated on the length of that. I just see it as that. I could be totally wrong. Here are the supports. You see there's no post-tension tubes in here. So this one I said that those piers are not post-tension. It's just all done through stirrups, reinforcement, the design of the arch, everything. And now we have the overhang. The loads are here and here, and you can see now. You can see how structurally it will transfer the load path through the steel. It's like a partial arch that is trying to, with a cantilever that is trying to share. And it's probably more on this side. That member, where the member is going to transfer the load, is going to land here, and it's going to try to get its on a cantilever. And then here, this one is in mid-span, so the load's got to do a span issue to work their way out to the left and the right, and work their way back down this load path. They're creating a force of pushing downwards also, so it's going to try to push this apart. So this also has a force of wanting to go north and south, but being stopped under tension with the reinforcement of the steel. If you can understand that, the tension of steel is compensating. I'm just sharing you some load path and some, you know, how it thinks. If you recall, they also have a U-shaped design here for a decorative U-shape because the last transfer of loads is with the steel here. And this obviously looks like a finished reinforcement, and it looks like it's being lifted and put in place. Okay, so, and there's the beauty of the tool. Hope you guys like that, and I don't know if I got anything else here for you. Let me scroll and see if they got something for us to troll at. Do you know a total of 210 concrete deck spans will be poured for the new Pensacola? Do you know? Well, how would I know that? You share the plans, bastard. Crews have currently poured 20 of the 105 for the new eastbound bridge. Here is a look at the deck. Poor work. And that's the machining and the follow-up machine as he's coming this direction. And there's the American flag. And that's the working platform as they work on down. And here's the other span. So how do they connect to each other? Interesting. I don't know. I don't think I know. If I had my life to live over, and could attain the smarts for a civil engineering degree. I would be good with 5 weeks ago, Floyd. Here's a look at some of the Pensacola Bay Bridge construction activities of the bridge. Blah, blah, blah. Click the photo to see more information. Well, that's on land. That's the driver. I pass. Now we're no longer on land. Tubes being poured. Okay, moving on. Findings of environmental studies conducted by the local students. All right, we already did that. Findings. June 12th. Point to an increase of the abundance of fish in near shore. Yeah, they like all that shit, man. They like hiding in concrete and around the columns and all that. So that's not, I don't think that's fake news. Trophy pieces are visible near the Pensacola shore for the eventual, I'm going to take a gamble there and enlarge that, for the eventual eastbound Pensacola. Okay. So here are the trophy pieces installed, and here's the spacing. So they can't be, so these are equally spaced, it appears 1, 2, 3, 4, 5. And then the last 2 are not spaced equally. But it's in the cantilever. The last 2 appear all the load to be in the cantilever, which are also 6-foot members that didn't change. So more load went there. But if we looked at the design, if you call that design, that reinforcing steel did not change. So you would have to extrapolate or assume, and now I got to open the link back up. You have to extrapolate or assume link here. That this reinforcement cage, as you can see, the cage is not more reinforced on one side or the other. That, and then you got to think about the dead weight. Is that creating a negative load over here? Is it like a tipsy-topsy thing? And that force would be transferred or translated. Where do you guys think the force would be if you topsy-turvy this, right? In other words, these are two. So in other words, there are more loads down here and then over here. It's a seesaw, right? So where does that force resolve itself? In a couple of places. One, it creates a more action here. So we could say it creates more of a shearing moment here on this cantilever. Oh, but it also creates a topsy-turvy moment down here where it wants to fall over. Yeah, the entire structure is that way all the way down. And it does create that load, that stress down here, creating more compression on this side and less on this side. More load on this side of this base than on this side. So more load on these 2 piers, piles, than on this side because it's got the extra length, the extra girder beam, the extra beam there. So you follow that. And yet no extra reinforcement was added. Apparently, now, I give and take, because I'm talking, right? Teaching a little bit. So you would engineer it that, since for the two are the ones with the greater load requirements, you would engineer their entire cage that way to take it. So in other words, what's ever required for the two on this side, just put it over here and do this also, all the same. So now there is no imbalance in it's all structurally the same is how this was done actually, to balance it. So this is going to be strong enough to hold another one over here if you wanted to. In theory, you could add another 6-foot, 150-foot member on this side. In theory, and not even in theory, in practice, you should be able to do that because these are all, they look symmetrical. So if you can put that load over here, you surely can put that load over here. And the piers are the same size of the 4. They didn't size the 2 piers on one side greater than the 2 piers on the other side. So you can surely put, and I'm calling somebody Shirley, right? Like the movie. You can surely put 2 more, another member on there. It's something odd to add to you guys to say you could do that. And let me move over. And here's those piers. Piers that they were loading with concrete and making a little service pier of some type. I don't know. Let's move over here. So come back to that. So they were adding the data. Let me see if any comments. And some 14 of you hanging in. Hello, brother lovers of bridges. This aerial photo the 1960 shows about what passed on the aerial. You guys can find Facebook. We're looking for data. That's going to be covered in concrete, and this box will probably be exposed, adding the power utilities. I don't want it to zoom in. I just told you what it was. Awesome. Here's the tent. Yeah, what I call the tent. Let's see if it's a tent. Casting yard is a busy place. There is where the still appears to be a tent that would come down here and cover all this. And those are the pier caps with the holes in them. And I don't see any reinforcement in it. So remember, all the loads have a punching issue, a shear, and it's only sitting on. So imagine those columns, right? Those piers. Remember, they're 36 inches on some, and some are 30 inches, right? So you deduct this, and you're left. You deduct this whole entire circle, the circumference circle, the radius, and then this is the load bearing capacity of the structure times 4. But whatever's here is where it's weak, is where all it has to cause failure. All it's got to do is defeat here, here, and here times, times all of them, 4 of them, for this to fall, to collapse. Now, if I were to crack this fully here, and fully here, and fully here, and fully there, it would still be wrapped around here and connected here, right? So what's left though is that little bit of shelf that's left from the crack from here around here. So it's on a shelf. To defeat it, I'd still have to continue my crack. If I knew how round this is, we can determine how much is on the shelf. And that's literally how much is load bearing on each one of those columns, not the center part. This is not taking on the load bearing. It's just grouted closed. It's void of load bearing. It transfers the load to the outside edges of those. So it transfers it around the top of here. It's transferring it and 4 on each one. And this one is imagine a big circle there. Its load points are around that circle. So it's on the outside edges of it. On the outside edges of that. If I could go back to that video, you would see what I meant. And do we have a pier here? Here they are here. Here's the structure. Here's the molds. They're the molds. And they are. I'm moving on. I get too fascinated by the smallest things sometimes. And moving on. That was then. This is now. And that's to protect erosion, as they obviously made a new roadway to service that. And scrolling down. May 19th. We're getting there. Memorial Day. Oh. So each one of the holes, you can see them voided. And you could see that when they made those cuts, as I was talking about the agitation with this tool, that when they were making each cut, they were below grade, below water level. They're down here, depending on the height of this, they're down here when they did it, and that's just shitty. There is the tool, a lift, man lift. And if I come to this one, I thought I saw the man lift in the background. Another image, moving on. The blue man lift, in fact. So now these pier caps create the weights and everything else. Even the dead loads of them are right now putting a hell of a stress into there. I can imagine that's going to be problems in the future. And I can imagine that no problem at all. Do you know, New Bridge, the heaviest single pieces are the pie girders. They got their names because of their ends assemble the Greek letter symbol of pi. These girders will form the 10-foot wide multi-use paths for the east and westbound bridges. Each pie girder is 150 foot long, so they're calling them pie girders. I call them girders, or maybe even, I don't think I call them eye girders. They're fabricated at the Bayou casting yard and transported to the thing. Okay, here they are sitting on there, and they're 10 foot on center is what they just said. No, they said on center, or they said lanes. Will form the 10-foot wide these girders will form the 10-foot wide They're not forming crap. They're 10 foot apart. All right, so they're 10 foot walkers. They're not forming that. What's this? Empty space for pie girder. Huh. Now I'm confused. So this is notched and that's notched. Remember I said the extra weight on one side? Well, that appears to be a cage, but what the hell are they talking about? They're calling them all pie girders, it appears. But then they highlighted it, shot saying empty space for pie girder. There's no empty space there. They appear to be sitting on, this is notched. I'm definitely confused on that. It appears to be sitting on that concrete pedestal on top of this guy. All right. No big deal. Below grade, below grade. They had them all above and now they're all below. Oh. That looks like a post-tension member. A tube. Cranes used to set the pie girder. Back to the pie girder again. It's a different girder. It's a different configuration. I think I'm starting to learn. This bridge has a step down. My dumbass, right? It has a step down over there. It's got a like decorative design, the walking path, and this might be, yeah. There we go, right there. There's the main road, and there's a step down. So this is the pie girder. This is the pie girder here. It's a step down. In fact, it's notched to allow for a little more equal elevation. So I guess if a car comes over, it's your ass. But moving on. Moving on, and we're wrapping it up, lovely people. We're wrapping it up. Oh. What we could get out of this, oh, they're trucking it out onto that bridge, onto there, then they snatch it off there and move it over. Gotcha, moving on. Oh, they have the fall protection on that one. Here's a waterline view of the work underway. Waterline view. What we got? Oh, nice. They number it. 1, 2, maybe 3 and 4. Okay, so they got my pedestal numbered, my what I call a capital or pedestal. Let's see what they call it. And they're gonna call it, whoa, number 3, caps. This is a pure cap. Now it says a cap. It's a cap of the cap. 4 is girder. 2 is columns. Oh, so much for that arch column. It's just a column now. All right, and pure underground, a column there. You know, this guy talks like me, this damn engineer. Footings that are positioned above the piles that have been driven into the bay floor. Okay, here's a waterline view there, visible from the bottom, as you can see, footings that are positioned above. So they call these the footings now. Okay, we would call these pure caps. On a ground, you call them pure caps, and you literally do this on a buried system sometimes, and it can work that way. My cat's approaching me. So and moving on. Friday. Here's aerial view of the Pensacola. Moving on. Okay, so we got the guys doing the concrete work, and we know they have a craftsmanship issue. They're not over water, so they're good to go. They got their hats on, protect each other. This is something. The lighting maybe, and too consistent. There's a guy working on a cage. An amazing view. So this is out on the road. See that structure, that steel? This is in the bay. There's the water in the background. There's that temporary cage thing they dropped down. And hey, cat, came over to say hi to me. My man's inside there. You know how you got in there, right? So they use a squeezing machine and they squeeze him in. And then when he needs to get out, they use a vacuum and they suck him out. It's simple as that. All right. Guys, answer that on your own. Oh, here's his ear being lowered down. And here is the reinforcement to stop it for lateral movement. I'll give him the A's on the balls on this guy to climb in there. It'd just be nothing left of them. Just anyway, here's another aerial view. I think I'd pass on that crushing thing, you know, in that crushing environment in there. I think I'd say, no, 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 no. We got to find another way. For safety reasons, there clearly is. It could be another way than the guy crawling in there. All right, here's a photo from the. Okay, May 3rd, another one. Advisory. Okay. Crews are working on the end vents. Okay, cool, cool. Of the new peninsula, right? May 2nd. Beams are set between the two vents. Here's an aerial view of the big. Okay, aerial view again. Damn it! Can't find this thing closed. I want to find them closed. Oh, there it is. We got some closed action going on. So we got some closed action on it. It is accordion, you know. So they are using it to some degree. Gantry crane. Thank you. Gantry crane. There's the mold. Awesome. They mold it somehow. They anchor it, pull it the hell out, put it out here to dry, rock it, keep on moving. They decided that's the configuration. There's the barges ready to rock it out. There's the pedestals already prefab. So yeah, some of them they aren't prefab and some of them they are. So you can see the bottom pedestals or caps or whatever you want to call them right there already ready. Concrete truck. For scale, that's a concrete truck. Oh yeah. This is down at the bent, the abutments. How about that? This is at the abutments, approaches. That's what they say. No, that's where they are. That's the only place that you see something like that. All right, so we got the crew here. I hope they got life jackets on, or at least tied on. Standing on some wood. This has already been aligned. No idea what he's doing out there, or this guy either, because he's parked pretty much down there. There the trophies. All right. Oh yeah, now we're talking. Visit for more photos. FDOT. Traffic updates. You son of a bitch. No more photos. Project news. Let's see if that gives us project news on this one. FDOT. Pensacola Bay Bridge project reaches construction milestone, June 29th. Yeah, they scrubbed it. Look, you can go to June 29th now. And let's see if. Pardon. Yeah, yeah, yeah. Scream your ass off. She's just going to run after you that way. Okay. You got less than 8 hours, buddy. 8 hours, you're going to get hooked up. And I got to cut your food off in a few minutes. It's a cat. I got to get it neutered, right? It approached her. She was in the yard hanging clothes, and this cat ran up on her, was screaming at her, and laid down, like went up to her, and she looked down. This thing as skinny as could be, man. It looked like it was friggin' the last leg, basically. She went inside, came back with food, and that cat just went at it. So it's her cat now, and he's I call him Einstein. The cat's so smart because I have another cat, another stray I found, right? So I call him Einstein because this cat is aggressive, and the other cat comes around, it screams at him and everything else. Not the one he wants to make love to, but he screams at him. But the cat that's in the house, giving him full berth, not getting aggressive or anything else. I find it amazing that he knows not to do that. Also knows not to spray this house, not to scratch anything up. It's friggin' awesome. All right, there's the riprap. We're talking right here's riprap. Protect the soils. Here's the alignment, how they're aligning it. So that's pretty. So his crews are working on Pensacola. See, they call it alignment stuff. They did not call it alignment stuff, but this is alignment stuff. Beautiful. So you can see how it's holding it. The driver's above it, and it's holding on to the one. Awesome. I love your noises. So here's the other one next to it. So that's beautiful. So, oh shit. You sound like me. You're too horny. Stop it. Oh, don't, I dare them. This better not be a damn meter for monitoring concrete. The crew checks temperatures of the concrete that has been placed in the bathtub from a waterline footing. Oh, it sure is, baby. So that's my other cat screaming at that one, right? But this one, Einstein, I call him. She didn't want me to call him Einstein. He's taking a hike. Yeah, you know your lesson. That's awesome. So look, guys, I started this video off about how, simple equipment you need. Well, they don't have a friggin' excuse. They have the equipment. They got the expensive gear too. They are monitoring temperatures also. This means, and I can end this video in a happy note, this means these bastards did know that they had some fucking failing concrete per this data. And this, believe me, this keeps logging. They have logs of all that shit. This keeps logs of it. Thank you, Kat. I'm trying to finish this video off. This keeps logs, and I'm glad I kept scrubbing this video. This keeps logs. This gets a screenshot, baby. This keeps logs. And let me zoom out. They can't be in denial. We're getting ahead of the game of everything if the cracks mean something later. And I'll just leave this video up for posterity. Somebody got to sue somebody later on. This is under this Pensacola Bay Bridge. That's their posting. This is their tool for monitoring concrete and everything else. The engineer stated that it's mix and also placement problems. This takes care of placement problems. It's drying problems related to drying problems. This fucking discloses drying problems. This is awesome. I don't even really need to go down anymore in this all this stuff, because this is the smoking gun that says you can't be in denial. You can't be in that place, the river, in Africa, the Nile, denial. Making fun. You can't be in denial with that tool right here, baby. Right here. This might be the new. Can I zoom out? Escape. Zoom out. Don't zoom out again. Fuck. I just screwed myself. Come on. Good. More zoom out. See if I can zoom out a little more. And they had to make the paved one more zoom. There we go. Fuck. One more zoom, because I need them tied in here. This part. And we'll keep the comments part roughly right there. And zoom back in. 25 shares. Let's see, we'll go with the comments. Let's see who's here, guys. 16 of you. Oh, no, I'm not just here. Good afternoon from Australia. Hey, Scott, what's up, baby? I finally found you got to watch the whole damn video just to get to this damn thing. I started off basically talking about, and I'm ending the videos right about now, is that this concrete and the problem with the concrete has been determined by Senator disclosing that they disclosed to him that the problem was in casting on your shoreline. We show the casting setup. They do it. I said, kind of said they need to have some type of protection while they're doing it. There should not be a problem in casting. I screamed and bitched about they should have tools and monitoring. There should be nothing like this, not like an FIU build. And I said they should have tools that would monitor temperature and everything else. And I'm just scrubbing their page right now, and all of a sudden going through scrolling their page, and I see this tool, and I'm like, oh shit, I know what this tool is, and I dare them to have a comment to say something like this: a crew member checks the temperature of the concrete that has been placed in a bathtub, quote bathtub, from form for waterline footing. All right, so specifically, they tested it for that. Now you see this yellow. This is the lead. The lead's on the other side. He comes in, he plugs, you get your readings. Oh shit, I can get a photograph of this. This will tell, for example, the temperature right now in the concrete is 138 degrees wherever they put this probe. And you want to see it not dry too much, and you want to know when it's setting, when it's curing. Ideally, this will also tell you when you can lift this whole thing up, when you can now use that gantry crane and lift it up, knowing that this at this temperature, even though it's still curing and all that, it's now set so far along that you can move the son of a bitch. And he's calling this a bathtub. I'm guessing it's one of their form work, their quote bathtub, and they're being ambiguous by saying bathtub. But nevertheless, this tool is a badass tool. This is the IntelliRock. You guys can look it up. Concrete Facts. And you can see this tool. You can see its capabilities. But nevertheless, they know what they're dealing with. Now they unplug this. They got a reading here. They go plug it somewhere else. It will give them readings and tell them that the concrete's going over the top, etc. This is at 1 hour and 23 minutes. You got elapsed time, and your temperature is 138 degrees. Now, this doesn't tell me anything because I don't know where exactly this probe is. I don't know the PSI of the concrete. I don't know what testing they did, and whether this tells them at this point corresponds to, hey, you can go ahead and pull this out of the ground. This is the screenshot I'll use. So when they argued or stated that they had concrete problem in the staging area, I'm saying, how the fuck could that happen? Because they got some serious engineering and monitoring going on with their concrete. And they're willing to lose the end of these leads. These aren't the cheap version of this either. These aren't these, so they're using a good the more expensive version of it, of testing. Now they're not going to lose all this line. It's another connection. So IntelliRock, right? So this guy has going. Let's just do that. IntelliRock software, IntelliRock temperature loggers. So we're looking at $2,000, right? And we look at ensure concrete strength. So you're monitoring awesomely. So when you tell me now that you had a problem with, and so let's see if I can show you. So here's the monitor, this guy's little hand, and that's the sacrificial monitor. It will be covered and gone. This is some freaking beautiful stuff if they're using it. This is what they should have used in the FIU bridge construction. Oh, there you go. So you see the concrete going in. I got a little tunnel vision, a little mono vision on this. And it will monitor all of the concrete temperature at that location. And what do we got here? 50 degrees and growing. Right, concrete has to be relative warm. It's going to tell you all the 40 degrees Fahrenheit while cured, and at least 50 degrees while curing. That this demands for supportive environment. Well, it's going to tell you when you can. This is going to be here. Let's go with this. I hope it can get you guys can hear it. Great. If I unplug the video, you're screwed. Hey, it's narrative. Watch this. As a result of temperature, okay, watch. This is what this thing is so great about, the monitoring. So when they say they installed it, I'm saying they knew they had fucking data. Okay. They had data that knew that those beams they installed didn't pass this their test. Poor quality. It's going to tell you all this awesome stuff. Oh, this is the cheap version. Oh, this is the badass version. This is for general contractors. Those cost maybe $10 when you buy them by a group, and you can literally use them from your smartphone. It's friggin' awesome, right? It's like $100 for a pack of them, but contractors they're cheap. They're not going to do it. So that's the wireless version of it, which is badass. This is the wireless version. So I wound up into that one. Sorry, guys. See if this is the lead version of it, meaning the plug-in version. $2,000. They're using it. As I told you guys, it's a small investment. Here's your crack monitors. I guess I'm moving on here. I'm moving on here for guys. Oh, I love the penetrometer. This is what I have. I showed you guys in the video. $277. Um, so moving on, it was concrete maturity meter. And so this is going to give you, let's see what we got here. Same, yeah, concrete maturity meter. This is going to tell you when you're going to be able to do, etc. You know, it's going to tell you when it was setting too quick based on your top surface is setting. Okay, let me help you out with this. If your top surface of concrete, since it's exposed to the sun, is setting faster than your bottom surface, and you're going to have this, it's unequal drying. You need equal drying, ideally from the inside out. That's what you want. When you don't have that, you're getting unequal drying. You're making weaker concrete. Anyway, we're moving on. Yeah, and so this is kind of cool. And I'll scrub a little faster, and maybe because that's a home run. I can hit this up. I can hit this up fast. Pure formwork. Um, these are the blade on their side. So that temperature would also tell you that it's now strong enough that it can now withstand, say, 5,000 pounds of PSI, and you can rotate this damn thing and lay it on the side without an issue. Nope, no data. I'm trying to racing through because we've been chatting it up. I think I showed you guys that already. And apparently this guy is misting the product on. All right. Okay, he's right down in the jammy jam. Sweet. Sweet. And there's a 10-foot lane. So that was 12. Oh, there's a step down. There is the pie section, as they call it, or whatever. The roadway. Thanks, Kat. Thanks. You're now going to be on the video numerous times over and over. He's, like I said, he's suffering, right? Any man would know. Check it out. Wonderful. Someone wondering how did the concrete truck use the deck get poured into the bridge? I told you, they move that shit. Hey, they put these on top of buildings. There's just a mixing section without this part. This whole piece here would go lifted on top of some buildings. And there's a truck being loaded, and there's the barge going out. Oh, come on, buddy. This truck's not being loaded. That's just going up here. It's going from the barge up to there. Hey, I'm gonna find you a girl tomorrow. We're gonna go girl hunting. So I'm just looking at it. No life vest. Only waist deep. You know, that's just. I guess, okay, let's see what they say. Here's some photos. What the hell's he pouring into? Moving on. What the hell's he pouring into? Is just a single one? I mean, can't see. Oh well, moving on. Moving on. They got any more crap in here? That was awesome. Let's see if they disclose their temperature testing again. I got a night shift, hauling materials, blah blah blah. Here's the this is gonna be a transition right there. Oh man, he's killing me. I'm gonna see you guys in a second. Comments, Instagram. And there's the bridge. Nope, the bridge showing on the wall there. It's gonna be concrete. That's a fucking nightmare. That's the craziest thing ever. You know, you gotta research these engineers, man. They gotta be crazy. I'm gonna put an arch made out of concrete to support it a mid-span. Awesome. Okay, 5, 4, and 3. 1 and 2. Let's see if they change the names of them this time. Let's see if they change the names this time. So 3, yep, and 1 is footings that are, whoa, 5. 5 is the underside of the bridge deck, which we know. So it's just spanning from there to there. And they change that to anything? They just call it a girder, and that's that pie one down here, I believe then. Man, he's hurting. Tomorrow, man, we're gonna take care of you tomorrow. Look, we'll take this photograph and talk about the crack now, potential cracks. We got a Dale. Dale, they look equal on the lane width, but we do not know. Right, same depth of girder can have different load capacities due to variations in pretension steel. Yeah, I don't, Dale. That's true, but this is a assembly line they got going there, baby. I don't think I think they don't care if one had less load than the other. They're making them all the same, man, just like those pure systems. I think it's beautiful and smart. Scott, I'm gonna go Saturday. Scott, I'm gonna go head on down to Cover Bridge again and hit up some stuff. So looking at this, look at that little lip they put on this one. It's an interesting lip. Um, so here's your, typically an I-beam. This would be larger. Larger is these are sized larger or smaller or larger. The top flange, the bottom flange, and the webbing, all three making up the strength of what you're going to get for deflection. And these are not. This has not been disclosed as tensioned at all. So this is all steel reinforcement and based on size. They are 72 inches in height, 150 feet long. And some of that span, since they're 150 feet long, if you could figure out this pure thing, they're meeting in the mid of the two of these, you would deduct that from the length. So I don't know what it's needed to crawl for these two to what's the support needed. This is the cantilever I was talking about. So all the load on here is in the cantilever, which is putting a negative load on over here. More forces on this side than that side. But remember, all the loads are coming down here together. But nevertheless, this is causing, since more loads are on this side. This is the one with the two, when they put the two on. So they're balancing the bridge right now, and then these two will go on. But interesting, my words balancing, right? So when this was installed, this one went in first. No, they didn't do this one. This one went in first. They usually would put the one further in first, and they work their way out. So I'd like to have seen that when they did it. I wanted to see if there was any action going on here. The first one, if it did lift up at all, that would have been awesome to see, to observe, to see if it rocked it at all. Or did they do this one first, and that's what that lip is for, to put a dead load down the center, and now put the outer one on. We can also see the formwork of this one, so we know. Remember, in the yard they did prefab this top part and then the lower part. We can see that this is your formwork, and this is the bottom pedestal, or they call them caps, sorry. And it's about equal with that one. And I wonder how much it changes as it goes down. I'd like to see that. They use a chamfer here, which is nice, and this is that fake radius. They do some patchwork in here. Here's where they got that cross stirrup, if you will, coming across here. Better yet, better yet, better yet. This is what we're looking at when I'm talking about that cross stirrup, the steel reinforcement, the cage. It's design. That's the cutter. There's the design. Going back to it again. There it is there. So going back to you guys, see if anybody's saying anything. Nope. And going back to this guy again. So this load is, this is all the dead load now. This load comes down here. This is now a span. And a span is very close to making it down to here. If we could put a straight line, we'd probably miss it still. This is probably still missing. Let's see if I can visualize that. If I could visualize that. Using the edge of this page, I'm not even in it yet. I'd have to come over more. And it's on an angle, mind you. The outside. It's on an angle. I won't be able to do this properly. Okay, that's the middle. We can probably assume that's in the middle of that. This is in the middle, and that's in the middle. Let's try that. Let's go to the middle. So if the middle looks like this, how do I hold that? Okay, I know how to hold it. That doesn't look like the middle to me. It doesn't look like the middle to me, although, I use that and using the photography. I got to think about the lens stuff. If they're in the same, let me think about that. If they're in the same, if it's just a person standing, you can imagine. I'm talking out loud for you guys. And now it's a person. Their head and their feet. This would be the feet, that's the head. No, I don't get this nose being different than the center of their cock right there. Um, wow, I'm leaning to that shit's off center. Then it looks like it's centered, but I'm leaning to that it's off centered. If I line this down, it comes sort of there. All right, so moving on. That's off center. Just everything's just weird about this. Love their assembly line they made and all this stuff, but it's just this configuration. I just think is weird. I don't get why you do this. It just creates too many stresses and strains and calculations you have to deal with. Just you had the extra room over here. Yes, it costs more money. Just use the extra concrete. You're already being cheap bastards, not using steel. This bridge is gonna need repair so soon. All right, I can imagine a lot of cracking on all of this stuff. I observe a lot of bridges with this design, and you guys can do it too. When you stop at bridges and you look up, you'll see all types of cracks in this structure. It's a terrible design. It should not be being duplicated. It should not be to being used. I said duplicating. Um, you saw the cage structure, and you understand that that's how it's resisting all these dead loads to forces. This is going to be getting tractor trailers and everything, and a lot of vibration. All right, so how are they dealing with the concrete to concrete here? I don't know. They pointing out stuff. They should point out. Tell me what this is. Is this some type of nylon bushing? I want to know how they're dealing with these two together. You wouldn't want them dry because that friction was going to wear that right out. It's going to tear it out. I want to know how they resolve that. How did they resolve here to here? It appears to be something there, and something here, and something there. I wish we had the plans. There's that I said that in another image. I spoke of that when they showed, and they said it steps down there, the pie. And I said, it does, but I said that one had reinforcement, as I recall, in images. And I didn't see these images, but it was other rendering stuff. And there it is. There's the reinforcement. So I don't know, what they're doing there. Obviously, that's got to be more custom and concreted. And that means it's going to take days and days to settle up. Settle. And this is around there. There's like a mini coffer dam action going on to protect it from putting shit out to the road, to the ocean, or putting stuff onto it. And I don't get that. So I don't know what that's left there. And this flap material here, don't get it. Don't get it. And already we have water stains. Appear to be water stains. And water leaks. Remember, concrete suffers alkaline silica reaction, and that just wants to mess up concrete. And this happens to be in water, so hopefully, I wonder how they dealt with that. I'd really like to know everything about their mix. Shut up, bitch. Anyway, it's a guy. Anyway, let's see what else they got for us. That's beautiful, and it's just a decking from there to there, and that's structural decking. So it's going to take all the load of the vehicles, the concrete, etc., and it's going to transfer the loads to these beams, girders, whatever you like to call them. And they don't have the cross bracing in here yet. What's the cross bracing? Should still go in. Wow, I just find it. Man, you scare me. Yeah. Oh, shit. How do I get out of here? Now he's going to mess with the other cat. You tell him off. You tell him. You want to go hunting? You want to go to the bars? He needs to get a girl. Let's go to the bars. All right. I think I'll bounce out of that. Yeah, it's a conveyor platform. I thought it was a conveyor platform. I wanted to speak up. Right over here. It's a conveyor platform. It's awesome. They use it a lot of times filling things and like that. You can go, just go as long as you want to go. Um, okay, how did that fit in my pencil? Oh, it's not a naked girl. It's a boy. And he's representing something. I was like, what's with the porn? And there are the beam systems. I want to see what the next, it'd be nice to see the next one's installed here to see how they, the one here, to see how they installed it. Are they going to load it in the center first? And if they didn't load it in the center, I'm dying to know how much, if any at all, it would rocket off the pedestal. Come on, show me one. So here are these guys out here on the barge getting ready for the lowering of a member, I guess. Oh, they're lowering the caps, they call them, on top of there. Nothing to see there, as we say. There's the governor, and he already talked about his $400 million job. And it appears we're coming to the end. There again is the 10-foot thing that a man pointed out that I was saying unequal. Oh, no, I was saying that the loads are from here, halfway between each one. And he pointed out that I was using, basically, well, I'm saying he was pointing out. So if he wasn't, I got you covered. He's pointing out that I was using the wrong line, middle divisions. And I don't know if you look at the video again, maybe I wasn't, but these loads work this way. For halfway between this one and this one right here is a span from here to here. This load goes down to this guy. And ultimately, when I got to the end, I said, this one takes less load. And these two share in this little bit of a load, which is an amazing amount, a little bit of load they're sharing in. And this is not connected. So this is now a cantilever, part of the load that it shares. But if we look at the literal load traffic now going over this again, this is riding on top of one of the I-beams. This is riding on top of one of the I-beams. Fucking awesome. But its load points are riding on each side of the I-beam, which is kind of still cool. It'd be nice to have a tire on top of that, one of the bitches. It puts 50% of the load on right on top of them. But, we don't have a bending moment, hopefully, to worry about here. You shouldn't have any at all, no deflection with auto traffic and zero with 80,000 pound tractor trailers, hopefully either. But let's go on to back to this. So this tire is clearly tractor trailers. They ride the right lane, right? No trailer truckers in the left lane. So if you think about it, if they were that smart, the engineer was, and I'm not saying they are because a lot of engineers stumble into shit. You would have your tractor trailers, right vehicles rolling down this. If you were smart, you'd share this little light ass human traffic. You'd have this one larger right here and move this one over, and you'd have both vehicles of the tractor trailer riding over top of an I-beam. I'm sorry, they call them, well, one would be called a pie and the other one would be called a beam. It's called a pie beam and the other one a girder, a beam. Anyway. So that would be the smartest move. Same thing here. The right tractor trailer. So the vehicle, right tractor trailers having them travel in the right lane. You've got the right wheels rolling down here. So you'd have more of your load here, transferring back to this guy, and then some over to this guy. And you'd figure out the calculations. If the tire's right about here, it's almost on there. But wouldn't it have been so much smarter to move this over, increase the deck span, the structural deck span ability of this pan, to handle the car traffic, but be real critical about no trucks in the right lane, saying no exception. And I guess if you had to repair the bridge on the right lane and a tractor trailer is going to come by, you're kind of screwed, right? So that means you would actually be smarter to add another girder system or anyway, I'm moving on. You guys get what I'm talking about when you're dealing with structural stuff. And moving on. Oh, here's a casting. And there's that shutter, formwork. I keep calling it shutter. There's the formwork for the pouring of the concrete or the last part of this. Keep want to call it pedestal, and it's called the trophy. And there it is there. This is held up by here down to this forms. I didn't mean to do that. The trophy pieces have been set at one of the locations close to the taller center span. Okay, so due to the height, the precast trophy pieces can't be installed directly into the water line waterline footer above the piles. Instead, a cast-in-place concrete footer is used to extend from the waterline footer to the bottom column portion of the trophy piece. The pipe at the right is delivering concrete. The precast footing forms are referred to as the bathtubs. The precast footing forms are referred to the bathtubs, which I told you guys a few minutes ago. I think that's what they're referring as the footer forms, and they are. Once the concrete cures, additional concrete can be placed in the yellow forms to connect the concrete trophy pieces. Shit. So here, we can't see, they're not showing the bottom. The one thing they're talking about, they're not showing the base. All right. Here's an aerial view of the construction. Yeah. This is what I was talking about in the original part of the video when you guys say that they're part of the contract to inspect and maintain the current bridge. And this is where I talked about the gamma testing, and I said I wonder if it was party to this. Reality appears as party to the existing structure. This is their repair. These are beautiful. Let's see if they talk about them. These are carbon fibers. This is reinforcing. Let me show you guys. Let's see if they talk about it. But this is a beautiful repair. I'm clicking on it. Carbon fiber. Woven fabric straps are used on the bridge's concrete beams along with an epoxy. The straps bolster the strength of the beams. So this is a repair and of an existing structure. This is some badass shit. You can teach your workers to do this very damn fast. Now, this is not completed. This is only, this section. They still have to come under, come back up, and probably got to do a lot more banding, a lot more. I don't imagine that. Let me figure out how this is working. So this is acting like a stirrup. And let me see. Yeah, I don't imagine that this is completed. That's letting you guys look at that longer so you can appreciate it. It's a way to do repairs. It's a pretty badass. And do I close this? Yeah. Wait a minute. An engineer shared that? Shrinking it. There it is. Nope. It says Eric Ingley, somebody. Engler. All right, so yeah, you saw that one. That's a repair too, but now it's been painted. See if you can find it. I can't zoom in anymore. The strips are there. It's been painted. The painting is going to help you also monitor your movement. Remember, painting is always going to sacrificial help you do that by default. And what do I have here? Looking for comments from you guys. And no comments. And going on. Blah, blah, blah. I don't want to hear about green stuff. We saw that photograph earlier. 400 million bucks. Oh, man, no pier install. No beam. And good news is, guys, we're running out February 9th. We're running out of data. So there's the yard again. They showed that. There will be 416 trophy pieces. You can see the extensions, how beautiful the system is, how you can extend it. This appears by default. They extended that one at the yard. I'm going to add that little bit of, you want to call it shutter, form work. And 100% right on that. Here's the spreader bar. They're moving in place. Blah, blah. I don't get to see that. And that's that picture that, the guy, something, whatever. Moving on. Damn it, nothing. Hey, George. George, my cat. Hey, George, come here. Talk to him. George is smart, too. He talks. George. George. That's right. I don't treat my dogs like cats. My cats I treat them like dogs. They're smart. They got a nose just as good as a dog. I have fun. I hide the food, and his job is to find it. And he finds that shit. Give me a second, George. I'll give you some food. The yard work, and we're wrapping it up. Look, look, look. This is the craziness right there. Concrete suspension. They're gonna put this silly ass, and we're not, I love arches, but this is just silliness. This should be steel. Hey, give me a break on that. George, your ass is gonna get it. I get it. George will act up when he wants food. He knows, he's taught me that if he acts up, then I'll give him food. He just tried to scratch my couch up. So I got you, George. Now he went down and laid down. He's waiting by my feet, saying, "All right, bitch, I scratched your couch. Give me my damn food." All right, George, I got you, baby. I'm the bitch in that case. So that's a nice way to end the video, right? Calling myself. Monitor traffic conditions. Nope. This is the craziest right there. This we will see shortly having structural problems. This right here. Doomed to fail. Correction. If this is badass reinforced, this span, then this will be secondary, almost decorative at that point. So if they can make this badass beam right here, then this will be secondary and so. But you can see they have no portals in here, nothing, no cross bracing. This is all done keeping its balance with these two legs, or you can call them, so we could call them, I'm trying to think of a name for those two of them. So it's the beginning of the hip. I can call them if it was a regular truss bridge, I would call them the hip vertical. So these are segmented at some point. They're not precast in the damn midair. So if it's segmented, I could say it's the first segment. And I could say the dual segmented first section of the arch, the base segment, the portal is section of the arch. So this is to keep it from rocking left and right, keeping it stable. Now, this is not the St. Louis Arch. So, you can think of it that way, right? This is, you can say that. But nobody's hanging a damn bridge from the St. Louis Arch, are they? They're just saying, stay up there. We're going to put people walking up there. In the St. Louis Arches, But this is interesting. So this would act in compression, right? But there is no abutment now. And I'll end it with this, talking about this real quick. There is no, come on, where are you guys? You over here for anything? Nope. No comments. 13, and we'll wrap it up with this one. There is no abutment. So right here, if these are also, so this is pulling down, creating compression in a typical arch, right? So it's just creating a compression, almost like the forces are coming from the top, because this is pulling down. But to so much, it's taking up the load. I don't know what the strength of this will be, the engineering of this, but it appears it's going to be awesome because there is no abutment for this actually kicking out, if you will. I don't know how this is going this way. Maybe they wrapped it around in so much steel that it's then pulling on this, trying to push on this, creating tension in here, which would be another awesome design. But you can see it's offset over here. So as if this is pushing down, what is it going to do? Blow this out? Well, obviously not. There's nothing, you can't have that. So it's got to also be under compression, basically all pushing down and transferring the loads in a downward to transfer down this column, a load path down each one of these columns, literally down this column. Not this one over here. It's nowhere near that. This one, but there's a but part. We need to know what the floor beam section looks like. This could be all fucking decorative, and it could all be from me shutting up if these are all just floor beams going this way. This, you would think it would be the way I'm saying it, if the floor beams went from one side of the bridge to the other, and then they're connecting at each one of these cables being a floor beam. But there's a but part. So now, with all that said, I'm wrapping it up. I think this is all decorative. That we're looking at a decorative piece. I want to know what this is about right here. Because I don't think you can do a floor beam system like this. It would just create too much drama right out here. Going here. without in this scale. If these are only 7 feet and this doesn't appear to be super lower down over here, in fact, it looks like it's lowered, raised up. You can see it's here, it's more concrete up. So this appears to be decorative, and that's my opinion of that at this time. And that's only with the rendering, you know. I love having plans and all, but so there's my take on that, and you see how I work. And I'll give you the link of this guy. Command copy, come over here, drop it down here, call this, and I'll give away a scene stealer. Scene stealer. They call scene stealer, right? Scene stealer. Anyway, you give away a scene or whatever. I don't know what it's called. Scene something, right? I'm going to think it's faux arches. And this is going to be my thing right now. That's what I'm thinking. So we'll see as this thing progresses and the cracks are disclosed, and we get drawings ultimately. But this is, you know, this is where it is. Thanks a lot for watching. Scott, I'm going to go see this Jimmy Jam. Let me put you up with some Jimmy Jam. Hold on. And come here. And all you guys, I hope you join in on over here. On Saturday, Scott, no come rain, no shine, hope. We get to watch these guys. Saturday, I hope to be live for you guys. If not, if it's raining or something, I'm still going here and I'll just do a videos. But this is the Burr Arch Bridge systems in Lancaster, Pennsylvania. There are multiples of them that are functional. I took you to one that was non-functional based on the date. I wanted to see what was going on. They didn't disclose that the fucking thing had a bar across it either. What's awesome though of that Burr system that we looked at is that if anybody else is watching that other video, they had seams here, every single one. Everywhere there was a bolt, which I find amazing. That appears to be a seam there. I find that amazing. And I like this one though, because it's got these this ties it in, locking this position in, north and south, up and down. I think that's awesome. That looks like it might be a seam. Someone asked me, how did they get the curve? And I said, I don't know. I can't see it. You know, I don't know if it's one piece or not, multiple pieces. I couldn't tell. We were looking from a camera. It was dark in there. But once I sent my drone in, I couldn't do the drone live. Once I sent my drone in, I could clearly see that they were pieced together. So ultimately, they were just small sections that were literally just, you know, having a little bit of curve at it. So you lay it out on the ground, create that curve in all your sections, cut out the extra pieces of it, put it back together, assembly it, and you've got your arch. Butting it together, and you create this compressive thing. You lock it in place with a single bolt, believe it or not, single bolt. But they did something different. If this one, and the other one, they did notching. So what are you looking at here? A single bolt. But you're looking at, I'm giving away scene stealers for the videos. You're looking at notching, if you will. Instead of notching the timber, they added these members, which in essence acts as notching, making this bonding into there. I like this. It seems like it's faster. The notching seems just, it takes away some material. You know, I like this one. I like this inversion of replacement of notching. So that I'm giving away some structural stuff on what I was going to share with you guys on Saturday. And now you'll be up to speed on that. I hope you guys watch that. Since you stuck with me this long with this one, hope you play along with this one. And I'll just have to do it live. I'm going to, you know, tell everybody I'm going to do the video. But you saw it was a damn wipeout with Google forcing me to use. Right now I'm talking using Google Hangouts. And I don't know how that's going to work with the phone. I guess I'll figure it out tomorrow. Maybe I'll try a test run. But sharing this with you and jumping back to, oh shit, did I just talk? No, there it is. I thought I talked to myself. Because using Google Hangouts, I'm so glad it loaded. If I loaded another, I think I just loaded Safari, and now I'm moving it over to the side. You guys can't see my Safari tab, I think. Nope, just, let's see. So you see it clear as day. Google's driving me nuts, man. All right, so here's the Safari tab. The Safari tab, here's the bridge. Cracking and temporary halts. This is from Roads and Bridges. All right, roads were temporary cracks worked twice on Pensacola Bridge, twice. And I told you that June 15th date earlier, right? So here it is, June 26th to June 27th. So I made the date a fuck up on the date. I messed up on the date. It was June 26th, June 27th. There's bridge closures, and also between April 5th and April 16th. Huh. Now I'm having problems with the other article. The other article is contrary to this because they had it down to like 24 hours, if you guys remember. Here's 24 hours. Sorry, I'm going to stick to my guns then. This is 24 hours. This means they didn't do gamma testing. Gamma testing, you really can't resolve it in 24 hours. This would be gamma testing. This is the first round. My thinking is they figured it out. They knew what they learned how to do the repairs, but since it was closed at this indefinite period of time, it appears to be indefinite. The bridge work deck work purely stopped twice. First between April 5th and April 16th, which I would then say this is very responsible, and it took 11 days to figure out what's wrong with the cracks. But they didn't share it with us as of yet. And again, between the 26th and 27th, 24 hours later, pretty much. So you have a crack that happened. They stopped work, it appears, and it took this long to figure out what was wrong. I'm saying it took this long. Who knows what they were fighting all along, and they came up with jack shit. And now this was 24 hours later on this one, and maybe they got the same jack shit answer. This is funny, though. I find not funny at all, but, you know, that this is 24 hours later. So is this the wrong problem? Same problem? And they say, hey, that's the same problem. We can do that. And they go, yeah, I think you're right. Go back to work. And they just start with back to work. And they said, take it out, replace it. Ideally, that would be what they're doing. I don't know. Okay. And then here's the data. So all the repairs all came within the ranks. This is reported by Roads and Bridges. And believe me, Roads and Bridges, they're sissies. They will not say something unless it's somewhere else that's been said. They do not go out on their own. So you can bet this was said somewhere else. That, oh yeah, there. Let me shut up right here. Source Navajo Press. All right, the inspection, elevation and cracks, and the decision to restart the work all came from the ranks of FDOT and Skanska. So it appears that, you know, that it's limited to FDOT and Skanska. And FDOT, they're just punks, man. I think they're just brought off. This is just the worst. They're just the worst. Nobody, NTSB, they don't have NTSB to hide behind now, and they're not releasing the crack data of this bridge. It's the same shit they did on the other one. But they were hiding behind NTSB. Now there is no NTSB to hide behind, because I understand it. This is this bridge is called, what the hell is this bridge called? Pensacola Bridge funding. And the funding, I think, is all state funded. So NTSB, you know, there is no government to step in. And that would be FDOT. And FDOT's not doing shit. Monday, the 309 bridge replacement will be a boom, all right. Come on. I think it's all funded by, okay, so it appears the county's got some sweat in the game. Yeah, I won't brush my teeth. I'm not doing it. So, anyway, so they keep trying to get me to brush my teeth. All right, guys. So, thanks for watching. And when I press this end the video, it's going to end the video. Oh, hell, how do I end the video? All right. I have to go over to Google Hangouts. So let's look at Google. If you got, tell me if you see Google Hangouts. Oh, yeah, I think you can. Oh, no, you can't really see anything there. There's some crazy shit that happens when you pull up the screen share. It does this indefinite. I forget, there's a technical term for it in computer terms. It does this indefinite thing. It's looking at a window of a window of a window. Oh, it's like reverb. So I'll put on a speaker, and in the beginning of this video, oh God, you guys got to get past the first 3 minutes of the video. It's reverbing. It's just hearing itself, and then hearing itself, then repeating its hearing itself. And it's over and over for about a minute. So please get past that. And this is what you're looking at here. an indefinite reverb going down to infinity from what I gather. So I'll just say good night. Night, N-I-T-E-N-I, K-N-I, those nights, all those. All right, and I'm going to press stop broadcast now. So good night, you pick your night.